devices as control plane bring up. Along with the control plane side between vSmart and WAN edges, we introduce single routing protocol. The only one routing protocol supported inside the fabric is OMP, Overlay Management Protocol. Routing table advertisement, or transport locator addresses advertisement, or service function route advertisement, or IPsec encryption key exchange, or policy distribution. So various functions will be carried through one routing protocol, which is OMP. And with the help of OMP, we do share the identity between all the WAN edge devices to form the data plane. Basically, the VPN tunnel gets established between the WAN edge devices. So VPN tunnel establishment logic and VPN tunnel tracking mechanism, and maybe like automated tunnel path selection procedure, tunnel tracking mechanism using BFT, bidirectional forward deduction mechanism, and path liveliness plus the path quality measurement. So data plane communication part. So we talk about the sd-wan component. Between the component control plane communication, between the component, we do have a data plane session. So data plane bring up communication, and also OMP routing protocol information. So these three logics will create the sd-wan fabric. On top of that, devices management will come in. So template. Using the template, we are going to apply the configurations to the WAN edge devices or to other controllers. Using CLI-based template configuration, or using the feature-based or feature template-based configuration. So the manner the devices are going to be applied with a device configuration using the template, we do talk about. And then policies. Using the policy, default behavior of the fabric will be influenced. A control plane, any route to be filtered, or any T-locks to be filtered, any ACL to be deployed, or any VPN topologies, or any flow communications we wanted to control. So data plane control as well as control plane control. So control plane policies and then data plane policies we do talk about. Whether we are going to introduce as centralized policies or the localized policies. So data plane, control plane, centralized, and then localized policy definitions and policy understandings, we do talk about it. Along with this, QoS, standard QoS tools, in which manner we are going to implement in sd-wan fabric. What are the tools are supported and configuration mechanisms for QoS and on the WAN edge devices. Then troubleshooting. Troubleshooting at the control plane, basically on the mutual trust, or troubleshooting on the control plane with OMP, or troubleshooting at the data plane, VPN tunnel establishment logic, or BFT related, or the tunnel data plane related stuff. Additional information like redundancy, route filtering, T-lock, direct internet access, BFT plus IWAN. Then security plus cloud and RAM. So connecting the sd-wan fabric with the cloud infrastructure, cloud connection for IaaS, infrastructure as a service, or software as a service. So cloud-based configurations, and then cloud-based reachability. And then we talk about the security features as well. So along with routing functionality, we can introduce the router to be with an additional application-based firewall role, or IPS and IDS role, or web layer security, DNS security, or AMP. So depend on the security features we wanted to enable additionally on the devices we can be able to enable. So we do talk about security and cloud and RAM configurations to the WAN edge devices. Then multi-tenancy, so single tenant, all the components, configurations, object modeling, everything will be under the single tenant. Similarly, multi-tenant, distributing the vSmart and WAN edge devices per tenant, and maintaining the controllers maybe like a vBond and be managed on the common instances. So single tenant infrastructure and multi-tenant infrastructure configuration plus whitelisting and control plane and fabric communication with the multi-tenant devices. Then vAnalytics and then REST API. So we just run through the manner vAnalytics works and programmability layer access into vManage using the programmability layer. What are the configurations or what are the verifications we are about to verify that. So basically, we start with sd-wan component, and then control plane mutual trust, OAMP, data plane, IPsec VPN tunnels or GRE VPN tunnel. And then we go with the template, then policies, security, cloud and RAM configuration, multi-tenancy, vAnalytics REST API, and then troubleshooting. Mostly like all the topics will be covered with the lab exercises, like adding or whitelisting the component, adding and then removing WAN edge devices, Cisco devices, WebTeller devices, control plane bring up, data plane bring up, OMP communication, template based configuration, policy based configuration, multi-tenancy configuration, and also REST API configuration. So all the lab exercises will be covered with it. So this is the standard curriculum, which we are going to follow. So now quickly you can go with your round of introduction, and then if you have any specific expectation, maybe you can put it across. So I will put some time on that, and then possible I will try to cover those topics as well.
Okay, I can go first if anyone wanted. So my name is Sergey, and I'm a network specialist with 20 plus years experience, working mostly for Cisco systems, and now working supporting Johnson & Johnson network.
Okay, great. About experience on SD-WAN and expectation on SD-WAN?
I have a good experience about SDA and data center fabric. So SD-WAN, yes, I have a general understanding, and building blocks basically is very, very similar to SDA and data center fabric. But in details, yes, it would be a ramp up for me.
Okay.
Let me join. This is Wisdom. I also have
Yeah, hi, Mr. Go ahead.
Yeah, can you hear me?
Yes, I can.
I was working for Accenture in the past 10 years. Previously, I worked for mainly routing, switching, support to many things, and I'm not specialist in any. With SD-WAN, I just started studying it in the past, say, a year.
Okay, all right, not a problem.
Yeah. So my question is everything.
Yep, fine, Wisdom. Yeah, thanks. Akhil, you can start. Piyush, you can go ahead.
Yes, hi everyone, this is Piyush. So I basically lead this team, right? I'm the track lead for the network data here, and I am more interested to see. So I did this training 2 years back for my existing team, right? And I think the same concept we wanted to bring in this team as well. I come with an experience of around 12 years now. Especially I am SME for wireless, but I also have experience in routing, switching, and SD-WAN to an extent. And I look forward to gain some more skills and learn few more aspects of SD-WAN using this training. One more thing, Parthiban, I actually don't see the entire screen. I think there is some grayed out area for me. I don't know if it's for others too, but I can't see the entire presentation. Is it for everyone else or just me?
It's a yellow. It's a yellow block, which is, I think, he's looking for participant lists. So once the presentation goes on, it should be, entire screen.
Yes, you are right. Yeah, I think now you can see the complete screen.
Correct. Yeah.
I've opened. I just have to call everyone. The call interviews.
That's fine. So, Parthiban, the idea behind the training is that we have the support for sd-wan coming up shortly to us, right, as part of operations. So, from that standpoint, I want this training to be more focused upon the operational areas and to just help us to pick up those incidents and work on those cases, right? I believe before this training, the team had gone through the basics of sd-wan, not all, but some of them. What we are expecting out of the training is that we should have some understanding of how the architecture works, and we should be able to work on the Cisco Viptela architecture at least. Yeah.
Yeah, sure. I'll try my level best to give the complete information inside sd-wan. Not only at the perspective of operation, as part of the concept wise, I will make sure that communications and then component, control plane, data plane, OMP, everything, how the things working inside that will help understanding the concept as well as for the troubleshooting.
Perfect. Thank you.
Hi, Sachin.
Hi, Sachin this side. I have 10 years of experience in the networking and telecom. And basically, I'm the wireless SME, and the troubleshooting point of view, I know the routing switching. SD-WAN is new for me. But yeah, on the wireless point of view, I know that template configuration, software-based controller and all. So few things are new here that need to be I understand. So I just one request, try to cover the basic fundamentals also.
Okay. So let me see how much you can do, because we don't have any relation with the wireless concept with sd-wan. If it is SDA, obviously wireless topics and then wireless concepts will be included. This is totally into WAN management.
Okay.
Hi, Vipin. You can go ahead.
Hi everyone, Vipin this side. Actually, I have around 11 plus years of experience in routing and switching. And basically in HCL, I'm part of network operations team. So here we are taking care of the operations. And as far as about the SD-WAN, I'm the new for SD-WAN technology. So I just wanted to know how we have to troubleshoot the issues related to SD-WAN, how the architecture is there for SD-WAN. So basically, what kind of issues we are facing day to day for SD-WAN.
All right. Yeah, we'll do that. Yeah, thanks everyone. Now let's get started with the session. Before we start with SD-WAN, Cisco's indent-based networking and some quick information on that. So indent-based networking are Cisco's SDN-based solution. What is the idea here is software-defined networking, standard SDN-based solution, whereas we can see controllers and then forwarding devices-based logic. When we are introducing controllers, the controllers are going to be for centralized visibility, basically device discovery or constructing the fabric, and also visibility into the devices, configuration of the devices. So centralized management, centralized monitoring, we can say it as. So through the controller, all the devices are going to be programmed and all the devices and the statuses will get collected. Forwarding devices, basically the forwarding devices are off intelligent devices. Traditional devices are like local control plane, local data plane, local management plane. Every device we will have to make localized CLA access based on the local configuration, control plane side or data plane side, operations will be permitted. But here we are going to introduce the controllers. Over the controllers, all the configurations will be pushed. Through the controllers, the forwarding devices are going to receive their configurations. Suppose if we try to introduce a router, then these routers are not going to take local configuration. These router configurations are going to be taken from controllers. Switches, when switches are introduced, switches are going to take the configuration from the controller. Instead of box by box configuration, each and every device's local management, centralized management, and also centralized administrations, we can go with it. Open solution for SDN, like each device will have the controller and then forwarding devices. The forwarding devices will not have the localized control plane. Basically, all the instructions will be collected from controller itself. But in case of Cisco, any forwarding device is introduced, this is in hybridized model. The devices will have the local control plane. The devices will maintain the control plane. They do have the data plane and they do have the management plane. But one thing, this control plane, data plane, management plane can be programmed from the controller. With Cisco, whether we go with ACA based data center solution or SDA based solution or sd-wan based solution, we can see controller, and this controller is going to discover all the devices introduced in the fabric, and all the devices are onboarded with initial configuration, automated onboarding, or basically manual configuration. Once they are done, the devices and then devices configurations will be pushed from here. And the forwarding devices like the switches needed with routing protocol configuration, routers needed with any interface IP configuration, or QoS or AAA configuration. So whatever the configurations we wanted to enforce, everything will come from the controller here. Though the forwarding devices are available with localized control, localized data, and then localized management, but these configurations and then the associated policies will be retrieved from the controllers. So we do have controllers and forwarding devices based logic. Whatever the configuration, whatever the management, whatever the troubleshooting we wanted to do inside the fabric, all the things will be carried out through the controllers. Forwarding devices will receive the instructions or will receive the policy information from the controller. Based on the controller policies, they will execute them locally. Based on that, they will program the function into the network side. So this is the hybridized design Cisco follows based on this controller forwarding devices hybridized SDN model. Cisco has SDA, software defined access. This is the solution for connecting and managing enterprises and then campus network. You can say like automation for campus and enterprise networks. Similarly, data center connecting application servers, APIC, leaf switches, spine switches, EPG design, contract-based communication. So they do have controller and then forwarding for the data center design using ACI. And similarly, software-defined wide area network, again from Viptela to Cisco. So software-defined WAN, we do have controller, and this controller is going to manage multiple routing devices which are connected to various transport. So irrespective of the transport connected over here, the controller is going to manage these WANage devices. Okay, so
okay, I have a question, very quick one. So most configuration, well, all configuration is sent from controller to onboarded devices, right? To the devices which is connected to the fabric, discovered by the controller. Is any local variation of configuration accepted? So, for example, if what if device has or some local configuration has been changed, IP address or some policy has been changed locally on device? How controller, how a final configuration would be merged? Would it be completely read by controller, or it would be merged, or what would be the preference?
Yeah, so we do have a different solution with a different variation. In case of ACI, suppose if you go with ACI based SDN solution, when the controller is available, we can be able to apply all the configurations to forwarding devices. If the controller goes offline, and we will not be able to make any configuration changes to the leaf and then spine switches. In the sense, completely local configurations are not supported in AC based design. But when we go with SDA or SD-WAN, so there are some options. As long as the controller is available, so we can be able to make the configuration through controller. In case controller is lost, and the devices will open up with the local configuration, local commands we can be able to apply, and then we can be able to restore the configurations or the device's reachability to the network. But the moment it becomes reachable to the controller, controller's configurations will be overwritten by the device's configuration. So at this moment, what you can understand here with SDA or with SD-WAN, the devices will take the configuration from the controller. In case if they lose the configurations or if they lose the connections with the controller, local configurations are permitted. We can be able to apply our local settings.
But if a connection to controller is still active, right, and you wanted to make some, I don't know, troubleshooting or local variation on the device, is it still permitted, or it's
they are permitted. So if the controller is available, configurations will not be like, we cannot be able to save the configuration, like we cannot be able to write the configuration. But if the controller is in offline, we can be able to apply the configuration. So the devices will take local settings.
Okay, thank you.
All right. So at this moment, you just keep an information, controllers and forwarding devices based logics with ACI or with SD-WAN or with SDA. So we do see these similar settings. So introducing SD-WAN, so powered by Webtela. So it's like dynamic WAN connection management, circuit load balancing. So automated load balancing across the available WAN connection, direct internet access. We do have a specialized configuration mechanism. Even this can be configured through controller. So we can log into the controller. We can choose what WANage or what WAN router is needed with direct internet access, and whether it is going to go with single direct internet circuit access or dual direct internet circuit access. So if this is needed with network address translation configuration, NAT configurations, we can be able to apply that. So centralized management using vManage, centralized orchestration using vBond, and circuit cost saving. So irrespective of the circuit, whether it is MPLS private circuit or internet public circuit or GSM circuit, we try to make a standard or the common mechanism of the data plane session. Like we just try to encrypt and encapsulate the traffic over any transport, and any transport to any transport communication path, we can be able to initialize it. For example, a WANage router connected to MPLS want to communicate with the other WANage router on the internet transport. These two devices can form the VPN tunnel and they can be able to communicate with each other. So like by making multiple circuit communications, and depends on the cost, and then we can be able to apply them, but still multi-circuit and then multi-transport communications, we can be able to initialize it. But as a small point, if we try to form the VPN tunnel between two different transport, the IP should be reachable. Then only so the transport IP should become reachable. Once they become reachable, we can be able to make inter-transport or multi-transport and its related communication. Along with that, multi-layered security, basically enabling the IDS, IPS, web layer security, DNS security, AMP, by introducing vAnalytics. So analytics inside the fabric, and also troubleshooting inside the fabric, we can run it. And application optimization is supported. So voice optimization, SaaS, cloud-based reachabilities, and application-aware dynamic routing. So AAR policies are introduced. And this scaling is very easy. because we just go with a horizontal scaling, number of controllers to be increased or number of WAN edge devices to be increased. So scaling is not a big issue over here. Like anytime, like we can be able to increase number of controllers, and then we can be able to decrease number of controllers. And single tenant and then multi-tenant design, so that multi-domain logic also we can be able to initialize. The point over here, existing WAN infrastructure gets automated through SD-WAN. When this is automated, when multiple WAN circuits are available across all the WAN circuits, dynamic and best path selection will take place automatically. If the users needed with direct internet access, so DIA configuration and enabling the NAT configurations towards to it, and enabling security features for that, connecting the fabric with the cloud-based infrastructure and applications and application optimization is required, we can do, and also scalability plus centralized management, centralized orchestration, we can have the benefit over the SD-WAN.
Perfect. I have a quick question. So basically, the solution provide overlay configuration, right, for data connectivity. But does it provide configuration for underlay, for MPLS, for underlay connectivity as well?
Yeah, we can do, but up to certain level. Standard routing protocols or standard IP address configuration, default route and then default static configurations, we can program through the controller. But enabling MPLS or LDP, TDP, so these kinds of features are not supported. Like at customer edge device configurations for routing functionalities, we can program automatically through controllers.
Okay, so basically you need to have underlay working, and on top of it, you would be rolling out SD-WAN solution. Is it
exactly? Yeah,
correct?
exactly. Yeah, exactly. Even this underlay network configuration, for example, interface specific configuration or transport and then transport specific configuration, we can automate through controllers. So underlay configurations can be configured through controllers.
Okay, thank you.
Any other questions from others? So predictable app experience, support for evolving business application, cloud on RAM for IaaS, infrastructure as a service, and software as a service, and collocation. So right security. So security bundle to be enabled on the devices, plus enterprise grade simplified IBM networks. So we manage so on-prem, cloud, multi-tenant, any deployment. So the point over here, so whenever we are going for SD-WAN deployment, SD-WAN components like controllers are virtualized. We don't have physical appliances for controllers, meaning that we manage vSmart, vBond. These three controllers are virtual machine based. So virtual machine based controllers, we can deploy it on-prem over the hypervisor layer, or it could be deployed on the cloud infrastructure. So we don't have any physical appliances. Okay, so on-prem deployment, cloud deployment, and then a single tenant or multi-tenant. And whenever the devices are introduced, and these devices can be connected across any transport, we don't have any restriction that MPLS based routers, they will talk with each other. Only internet based routers will talk with each other. So there is no restriction. So MPLS connected routers can talk to internet, and then private devices can talk to public, and then vice versa. Once the IP L3 reachability is provided between WAN edge devices, so any transport communication path, the underlay and then overlay network path gets communicated. So any service and then any transport, any location, so branch or co-location or the cloud-based infrastructure, WAN edge devices will have a reachability, and WAN edge devices will have the fabric reachabilities for control plane and then data plane operations. So SD-WAN, okay, we do have public transport, private transport, MPLS, and then internet. branch and then campus, so we can connect over the internet or through the private circuit, and applications moving towards to the cloud. So when they are moving towards to the cloud, whether it is software as a service based application or infrastructure as a service based application, so we can own IaaS based data center with our own managed devices to connect with the fabric. So we do talk about all the features in detail, but at this moment you remember cloud-based reachability for SaaS and then IaaS-based applications. And the way like various branches, uses, and then data center devices plus various transport options available, and then how they get connected into it. So direct internet access. So single internet connections are dual internet connections. So SaaS-based applications reachabilities. And unified communication support over sd-wan. So again, UCM connections and also voice, maybe like IP telephony devices to be connected over the sd-wan. So they are identified and they will also be integrated with existing sd-wans. So SD-WAN plus umbrella. So Cisco umbrella gets integrated with the SD-WAN solution. So by introducing Cisco umbrella, all security features and then security configurations can be carried over through Cisco umbrella. So Cisco umbrella subscription, once we are able to have umbrella subscription, using that integration between SD-WAN and then umbrella and associated configuration management, we can run. So partners and then all right. So we start with the concepts. The first information what I want to cover here is the component. Okay, with SD-WAN, we do have controllers and then forwarding devices. So this controllers basically like vBond. So vBond is the orchestrator. vManage is the management device, and then vSmart centralized control plane device, and then vAnalytics. So there are like 3 controllers will be placed, and each controller will have its unique function. And forwarding devices, basically routers are introduced as the forwarding devices, and these routing devices can be from a branch or maybe from a campus network or from the physical data center or cloud-based data center. So whatever it may be the location, we can introduce physical routing appliances or virtual routers also can be introduced. So forwarding devices are the routers. In this place, we do have various options, Viptela routers to be introduced, Cisco routers to be introduced, Cisco CSR, Cisco ISR, Cisco ASR. So we have various options of introducing Cisco or Viptela routers as the managed forwarding devices. So controllers, vBond, vManage, vSmart, and then forwarding devices are the routing devices like Cisco and then Viptela devices. So these devices are connected to the place wherever it is like needed, and they do have IP reachability. L3 IP reachability is maintained, and this IP based reachability communication for control plane or data plane session gets automatically enabled. So vBond, vManage, vSmart, the controllers, manage devices, forwarding devices, vAnalytics, basically for the analytics of functions. So cloud ready WAN, so the physical reachability to SaaS applications and then IaaS based applications. About the jargon, so manage devices, vEdge routers, Viptela, and then CH devices, Cisco, vSmart, the controller, and vManage, the management application or management controller, vBond, the orchestrator. So vBond sits at the orchestration plane, and vManage at the management plane, vSmart control plane, vManages in the data plane. So just to get a quick information about
you. You please go to the back slide.
Yeah.
Okay. Just a minute.
CH and VH, it would be pretty much interchangeable. It has a relation to a vendor, right? It is a Viptel or Cisco, but basically it's just H device.
Yes. So general terminology, you can call it as a vantage. When we say VH, these all are the Viptela devices. So Viptela routers, they run with Viptela OS. It's not Cisco OS. They will run with Viptela OS. So commands are different. So interface configuration, VPN configuration, associating interface inside the VPN, enabling the routing protocol, transport configuration. So everything is related with Viptela specific. So we can say like VH 100, VH 200, VH 1000, 2000. So Viptela physical appliances will be configured using Viptela OS. The CHs are Cisco devices. So existing Cisco ISR and then ASR. So these devices are upgraded with Cisco iOS XE SD-WAN image. Standard iOS will not be supported with SD-WAN. So we will have to upgrade Cisco existing ASR, CSR devices to Cisco iOS XE SD-WAN. So you can say like this is iOS XE SD-WAN image to be upgraded so that they can be integrated with SD-WAN. So CHs basically Cisco boxes and then VHs Viptela devices. Even Viptela or Cisco, they support both virtual machine-based routers and then physical routers. Even Cisco also CSR virtual, ISR virtual. So virtual machine-based routing or physical ISR and then physical ASR we can introduce. Advantages in physical form factor or virtual form factor, both will be supported.
Thank you.
So Parthiban, we are not going to talk about the V analytics here, right? That will not be part, but that's a component which is part of the SD.
We will talk about not in detail, but at least to give a visibility about V analytics, I will show that.
Okay.
Right. First component as the V-bond in orchestration plane. So the reason to introduce V-bond for the centralized authentication. Okay, all the components introduced in SD-WAN fabric, first they should be authenticated and they should be authorized by V-bond. vManage, before vManage is about to manage other component like Vanages or these vSmart. So vManage should be authenticated by a vBond and vBond should authorize the vManage. Similarly, vSmart, to permit the vSmart inside the SD-WAN fabric, vSmart should be authenticated and then authorized by a vBond. The Vanages participating in the SD-WAN fabric, they should be authenticated by vBond. So vBond is the primary controller which is going to authenticate vManages, which is going to authenticate vSmart, and which is going to authenticate the Vanage devices. So the centralized authentication and authorization device is utilized using the vBond solution. The centralized authentication and then authorization, for them, we are introducing the device certificate. So device certificate based authentication and also authorization. Using some local configurations, we are going to validate them. But as a first information, what you can do, vBond is basically for authenticating and authorizing the components which are permitted inside the fabric. Authentication is basically based on the device digital certificate. We don't introduce any other mechanism for authentication like username or password or IP address. Instead, we try to go with device certificate based authentication. At any moment, any controller or forwarding devices are introduced, we have to make sure that the device is available with its unique device certificate, and also the device is updated with the trusted root certificate. If root certificate and device certificates is properly installed, then only the device can be able to participate inside the fabric. whether it is a virtual machine based controller or the router, physical appliance based router C edges or V edges. They are supposed to have their unique identity like as a local device certificate plus root certificate updated. Based on that, these devices are validated and the devices will be allowed to participate inside the fabric. So VBON, centralized authentication and then authorization device. So centralized authentication takes place based on the device certificate of each component available in it. Then second component we try to introduce as the vManage. So vManage is basically for configuration, management, and troubleshooting. For an example, if I need to apply a configuration towards to these Vantage devices, so this routers gig 0x1, I need to apply an IP mask gateway routing protocol configuration. So now this device configuration you want to enforce. So as an admin, we can log into vManage. Through vManage, we can be able to apply the configuration to the end device. So some of the configurations to be enforced to these Vantage devices. So vManage takes all configuration from the admin and configurations can be enforced to these devices. And this branch router needs and software upgrade or this device needs and software downgrade. So upgradation and then downgradation. So device management, you can do it through vManage. And campus devices, we want to make an SSH connection. We want to verify the control plane status, data plane status, OAMP status, configuration status. Again, management or vManage is going to work on it. So devices configuration, devices management, devices login, and then devices visibility troubleshooting can be performed through vManage. So apart from vManage, we don't have any other control plane communication path or data plane communication path with Vantage devices. So vManage is not part of the control plane in the sense we cannot enable routing protocol in vManage. vManage is not part of the data plane in the sense vManage is not participating in the VPN tunnel or VPN communication path. So vManage only in the management plane, the devices management and then devices configuration, this is going to apply it. And similar way, we do have vSmart. And when we talk about the vSmart, this is the control plane devices. And this control plane is initialized with routing protocol. For example, OAMP is a routing protocol. vSmart with Vanage's OAMP routing protocol adjacency will be built. Whatever the routes to be distributed from one Vantage to other Vanages, the distribution will go through the vSmart. So vSmarts are equivalent to BGP route reflectors. The way like BGP route reflector is forwarding the routing updates from one route reflector client to other route reflector clients. So the similar behavior vSmart is going to function. So it takes the routing information from Vanages and forwards to other Vantage devices. So this is how like vSmart is going to function into the network. So VBON, complete authentication and then authorization. And when we talk about the vManage, centralized management and then visibility troubleshooting, OAMP and then control plane management through vSmart, and forwarding devices are the WAN devices. Attaching the local LAN subnet, configuring the local routing protocol, routes coming from routing protocol, distributing to other devices, and then forming the VPN tunnel, VPN session. All the things will be controlled through the Vantage devices. So VBON at the orchestration plane, vManage at the management plane, vSmart at the control plane, Vantage devices at the data plane. In SD-WAN, VBON, vManage, vSmart. So these three components we call it as controllers, and forwarding devices are the Vantage routers. Okay, so 4 components and then 4 functions. Any questions? I will address on top of that.
Very quick one. So basically, vSmart sends the forwarding information to VHs, right? And this is if situation is kind of stable, no additional, let's say, updates is required. So in case of, let's say, vSmart goes offline, the VHs would be using the existing information to forward the traffic, right? Is it correct?
This is supposed to be, but since it's a routing protocol design, Vantage vSmart forms OMP routing adjacency. In case vSmart goes down, automatically routing adjacency goes down. Whatever the routes learned through vSmart by OMP, obviously like OMP neighbor is down, the routes will be withdrawn from the routing table. So the device will go in an isolated state. So at least one vSmart must be present and at least one OMP session should be communicated with other devices. So we don't maintain single vSmart inside the fabric. We try to maintain 3 vSmart per group. In case 1 or 2 failure, at least the least one will be able to distribute the routes from one Vantage to another Vantage devices.
Okay, so this part actually creates an adjacency and populating a routing table, right? But adjacency from VH, it would be pointing to another VH, so it doesn't go through vSmart.
No, we don't have any direct routing adjacency of OMP between Vanages. Always the routing adjacency takes place from Vanages to vSmart 1 and then Vanages to vSmart. This is how it goes off. And second redundancy, we try to maintain the second vSmart. For example, I try to take second vSmart OMP session, OMP session, OMP session. So if any subnet is introduced here, this subnet goes to vSmart 1, to vSmart 1 distributed. Same subnet goes to vSmart 2 and this is distributed. So branch router will have path number 1 via vSmart 2 to reach the branch router and similarly like path number 2 to reach it. So 2 paths available and best path will be selected using the local designs.
Okay, so data traffic would go through vSmart in this case.
Only the control plane updates will go through the vSmart. Data plane will be locally connected, like locally communicated. If you could see MP or BGP, IBGP designs, when we go with IBGP, route reflectors and then route reflector clients. Though we are configuring the route reflector, if the route is moving from routing table is communicated from route reflector client to route reflector client, the next hop IP address is the original IBGP router which generated the route. So routing update will go from one device to another device via route reflector, but the next hop IP address will not be updated. Similar behavior is followed here. So,
okay, so that was my question. Yeah, that's exactly was my question. Okay, thank you.
Yeah, fine. Any other questions? Others?
So Parthivan, let's say for example, I update a policy. Can you hear me?
Yes.
If there is a policy change, let's say for example, I am pushing a new VLAN using the vManage, right? And how exactly, let's say if I see that one of the controller is down, right? How exactly the policy, what will be the flow in that case?
Okay. The components are placed in the fabric, but they will have their independent features and then independent behavior. They're not depend with each other. Let's say when I'm introducing a vManage and then Vantage devices, they establish a session. So basically this is net config session. Using the net config session, if I'm choosing data center router number 1, for this router, apply a routing protocol configuration or interface specific configuration. So vManage uses netconfig underlying protocol to push this device configuration. So what the point over here, the device, when the routers are introduced, the routers can take local configuration using the traditional mechanism like console access. Using console access, apply the device configuration or make an SSH, make an telnet connection and apply the configuration. Similar behavior, the device iOS configurations will be carried from vManage. This is independent. The same way, when we are introducing vSmarts and then Vanages, they establish routing adjacencies. For example, here OMP protocol enable, OMP protocol enable. These two devices will become OMP neighbor with each other. if any subnet is introduced, let's say I'm introducing 10.x, there is a LAN subnet is introduced. When 10.x LAN subnet is introduced, this 10.x LAN subnet routing table update will go to vSmart, and then vSmart will publish to all the WAN edge devices. If branch is connected with the LAN subnet like 20.x, now this 20.x is distributed to vSmart, and then vSmart will exchange to other devices. So routing table updates generated locally will be communicated to other WAN edge devices via the vSmart. So vManage and then vSmart, they are independent with each other, enabling OAMP protocol, forming OAMP adjacency, learning the routes from an WAN edge device and advertising to other WAN edge devices. This is controlled by the vSmart. And any device is selected, the device's interface configuration, NAT configuration, VPN configuration, routing protocol configuration. So device specific configuration, vManage is going to do it. So it's like independent operation. So we need to understand what is the independent behavior of vBond, independent behavior of vManage, independent behavior of vSmart, and how these controllers are put together is going to manage the WAN edge devices. So this is how we need to understand it.
All right. Okay.
Others, any other questions before I go to the next slide? Fine. So we talk about each component in detail one by one. So vBond orchestrates connectivity and first point of authentication. And when they are deployed, so this is an option like when vBond is deployed on the cloud, it requires public IP address. So vBond should reach all the vManages, and vBond should reach all the vSmart. vBond should reach all the WANages in place. So then only like first point of authentication. So authentication, all the devices will reach vBond, and they will share the digital certificate. By validating the digital certificate, they will be authorized to participate inside the fabric. So requires public IP address, facilitates NAT traversal, meaning that if a WANage is connected with internet-based transport, and this internet-based transport, if the router is behind the, for example, it's available with NAT configuration. If this is not with direct internet access, so vBond collects both public and private IP addresses of the WANages. So WANages and associated private IP reachability or public IP address reachability, all the public IP address and then private information should be collected by vBond. When a WANage is trying to talk to vBond for authentication, vAges associated IP addresses information should be collected, and this will be distributed to other devices inside the fabric. So facilitates NAT traversal. If a component is behind the NAT using private and then public IP addresses, vBond collects both public and then private IP addresses. All other components need to know the vBond IP or DNS information. So we need to have a basic configuration. Whenever we are applying the configuration, for example, vManage, when we are initializing the vManage, in vManage, we are supposed to give vBond. The vBond is listening on the IP address of, let's say, 63.0.0.1. This configurations we have to locally place it. In vSmart, we have to place the vBond IP address 63.0.0.1. Across all the WANages, we must give vBond IP address, vBond like 63.0.0.1. So vSmart, vManage, and then WANages, they are locally configured with a vBond IP address. Based on the locally configured vBond IP address, they will reach the vBond and they will perform their initial authentication. Again, as a standard process, either we can configure the IP address or we can configure the fully qualified domain name. So DNS is required. Using fully qualified domain name to IP resolution using DNS, name to IP is resolved, then devices will talk to its vBond. So all other components need to know the vBond IP address for or the DNS information. So authorizes all control connection whitelist model. So this vBond will be updated with whitelisted database or whitelisted entry. So we are supposed to whitelist the all the controllers. For example, whitelisted vManage, and then whitelisted vSmart. So all the details we need to whitelist, and then whitelisted vManages. Based on the locally generated whitelisted entry, the components gets authorized. When a vManage is trying to authenticate with the vBond, vManage is validated against the whitelisted.
That whitelisting is done at vBond?
Okay. Normally what happens? Whitelisting is a fabric configuration. So this whitelisting configurations, we will do it through vManage, and vManage will distribute the information to vBond and will distribute to other controllers. So configuration, all configurations will go through vManage, but vManage distributes some basic informations like whitelisted controllers and then whitelisted vManage information to all the other devices.
Okay, fine.
So the whitelisted informations are validated. So once the vManage or vSmart or vManages are in the whitelisted, then authorization and then authentication will take place for that. So authorizes all control connection using whitelisted model, distributes list of vSmarts to all vEdges. So this vBonds, okay, distributes vManage information to controllers and then controller information to vManages. We will discuss this information at this point in detail about control plane communication, but as a role for an vBond, you understand orchestrates the connectivity, first point of authentication for the entire fabric components, and placed basically using public IP addresses. Any device is behind the NAT, both public and then private IP addresses are collected, and configurations we need to do at other devices. Apart from vBond, all the other components are configured with IP addresses, and all the devices are authorized using the whitelisted entries, and distributes the list of controllers to vManages and vManage information to controllers. Any questions, any points to be discussed here? All right. Then vManage, centralized provisioning, centralized monitoring, simple graphical dashboard, supports REST API. So we can make programmability layer access into vManage, or standard CLI access and then standard GUI access. vManage runs with syslog, SNMP, and then netconfig session. So basically, we run netconfig session so that vManage can push all the configurations towards to its local component. So vManage is basically for the fabric management. And then vSmart, centralized brain of the solution. vSmart establishes OAMP peering with vManages. So we do see a routing protocol or control plane communication between two devices. One is vSmart and vManages. So remember, vManage to vManage, we don't have any direct OAMP adjacency or direct routing protocol communication. Always vManages will form adjacency with vSmart, and over the vSmart OAMP adjacency, routing table or any control plane data to be exchanged, they will be communicated. So OAMP is the routing protocol, runs between vSmart and vManages, and also runs between vSmart to vSmart. So vSmart acts like the route reflector of BGP, taking the route from branch or taking the route from the vManages and then distribute to other devices. By introducing the policies, control plane policies, the default behavior of the fabric can be modified. What route to be permitted, what client or the LAN subnet to be denied, and similarly, like what topology to be built and what control plane and then data changes or influences we wanted to do introduce inside the fabric, we can so do that. So by introducing centralized control plane and then data plane policies, like the behavior of the fabric, we can be able to influence it. And orchestrates data plane connectivity between edges. So vSmart exchanges all Vanage's identity information about the transport, how many service provider links are connected, and what IP address the devices are available with it. So vSmart collects the transport information, and using the IP address over the transport, this is communicated. When IP addresses and then transport informations are communicated with each other, it helps to form the automated VPN tunnel with each other. In the legacy design, in a standard network, what we try to do, two routers, two firewalls, or two VPN devices, manual configuration about peer IP address and then peer key, peer details, we try to do it. But in case of SD-WAN, VPN tunnel creation and devices identity exchange will be automated. We never give the private peer key information or peer identity or peer IP information. So via OAMP to vSmart, all transport information, transport public or private IP addresses are communicated, and using the received public or private IP addresses, VPN tunnels will be built. So vSmart forms the OAMP adjacency with all Vantage devices and acts like an route reflector and forwards all Vantage devices routes from one to the other devices. And by configuring the policies, we can influence the default behavior into the desired behavior. And OAMP or vSmart helps to form the VPN tunnel or automated VPN tunnel between the Vantage devices. Okay, so vBond for its unique function, vManage for its unique function, and then vSmart for its unique function. Any questions in this, please? No. Okay. 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 So with SD-WAN, whether we introduce Viptela routers, VEdges, or Cisco routers, CEdges, okay, apart from iOS based configuration change, okay, then technical configurations and then technical informations are unique. Let's say here VEdges, we can configure OAMP, Cisco devices OAMP. So VEdges forms the OAMP adjacency with the vSmart, and then OAMP adjacency from CH to vSmart. So vSmart receives a standard type of routing table update from both CEdges and then VEdges. So Cisco updated the iOS. It's not sending the Cisco based OAMP routing table update. Instead, Cisco devices are going to send Viptela OAMP routing table update. So as vSmart's perspective, both the devices are considered to be the similar devices, and routing table updates are communicated with each other. A subnet is introduced here, and subnet goes to vSmart, and then vSmart will advertise to CEdges or to other VEdges. But just to avoid the routing loop, because if the route is communicated from one site to vSmart, and same route should not be published to here. So just to identify them, every branch, every campus, every data center, every home office, we try to assign a unique number called site. So we try to say data center with site ID 100, and then campus, first campus site ID 200, branch again 300 and 400. So we assign these site IDs. If two devices, two Vantage devices belong to the same site, if there is a routing table update in site number 100, the same thing will not be sent back to site number 100 with other devices. But site number 100, routes will go to 200, 300, 400, they will be classified. So it's kind of BGP, okay, you can say like loop avoidance mechanism. So though are placed, VEdges like Viptela devices are placed, all of them are considered to be the standard Vantage devices using standard OAMP routing table advertisement. But just to avoid the routing loop, basically like site IDs are configured for every Vantage devices, If the route is learned from a specific site, and if other vantages belong to the same site, they will not be sent it back.
So I have one question. Like suppose at this campus, I have installed one router VH. So what is the process actually it is going to follow to like get the configuration and get it live?
Yes, we talk about these things in the next module. That's what we have a control plane. We need to make sure that digital certificates are populated, and also they should have vSmart OMP adjacency, and then they should receive the TLOC specific key information, then VPN tunnel, and then additional configuration about template policies will come in picture. That will be like sequences of
Okay,
flow will be happening to the devices. We will discuss that in further slides.
Yes, thank you.
Okay, all right. Then Vanages. So Vanage routers. So Vanage router of the site leverages traditional routing protocols like OSPF BGP. Okay, so remember when we talk about the Vanages, so Vanages, they do have two-side communication. One side towards to the fabric and other side towards to the LAN. So when they are communicating to the fabric, we manage vBone and then vSmart. So vSmart is a only one place routing protocol comes in. So we introduce OMP routing protocol. So to the fabric with vSmart, OMP routing protocol is initialized. Towards the LAN side, we have an option to enable BGP, or we can enable OSPF. Or if Cisco devices, it supports with EIGRP. So static routing we want to enable, we can do, or static default routing we wanted to configure, we can do that. So Vantage routers can be configured with LAN side routing protocol and then fabric routing protocol. Fabric routing protocol is fixed, like this is always the OMP protocol, but towards the LAN side, BGP or OSPF or EIGRP, static or static default route configurations, we can do that. Okay, now this Vanages, okay, one side the LAN side routing protocol, other side fabric routing protocol. So BGP to OMP, OSPF to OMP, EIGRP to OMP. So redistribution needs to be configured. So we do redistribute LAN side routing protocol subnets into OMP and received OMP routes redistribution into LAN side routing protocols. So Vanages runs with two different routing protocols, and for the communication between LAN side and the fabric side, we introduce the redistribution process, which is very similar if traditional router runs with two different routing protocol, redistribution from one routing protocol to other and vice versa. So similar configurations we are going to do it here as well. So LAN side, what VPN, what VRF, what routing protocol we try to configure, and this routing protocol will get redistributed into OMP and vice versa. Okay, so leverages traditional routing protocols to the LAN side and gets redistributed with OMP on the fabric side. Applies policies on the data plane. So since data plane is available on the Vanages, we try to apply the data plane policies like ACL configuration or QoS configuration or any kind of flow configurations we wanted to, or monitoring configuration we wanted to do. They will be applied on the data plane on the Vanages. Establishes control plane pairing with vSmart, provides secure data plane. So enables IPsec or the VPN based reachability to other Vantage devices. All the traffic coming from the LAN side gets encrypted and then gets encapsulated, and then over the underlay path, the traffic is communicated. So provides data plane secure like VPN path between Vantage to other Vanages. And Vantage devices can be in hardware form factor or it could be in the virtual form factor. So virtual VNF, virtual machine based routers or physical appliances or physical routers can be introduced as part of the data plane. So Vanages and they run with two different routing protocols, fabric side and then LAN side, OMP adjacency with the vSmart, and VPN tunnel session with other managed devices, and supports with the physical and the virtual form factors. Any clarifications in this, please?
Very quick one, if I may. So on VH, the LAN side, is it also, as I understood, it's also managed and configured from vManage, or is it configured by other means?
No, it is configured through vManage.
Through the manage. And VH, I mean, could it be part of another solution, for example, SDA? Because,
Yes.
I mean, on one side we have sd-wan, right? And LAN side, could it be configured by other solution?
Yes, we can introduce it. Yes. So vManage can be integrated even with ACI, and it can be integrated with SDA. Since like vManage is a centralized controller to controller integration process through orchestration layer, Cisco supports.
Okay, thanks.
Yeah, and it's like standard routing table updates. For example, I'm connecting a LAN subnet. So with this Vantage router, I do have a LAN subnet connected with gig 0 by 1 subnet. And this is connected with 10.10.10.254/24. So this is the subnet connected. Now what happens? This 10.10.10.0/24. So this subnet is on the LAN side. This is advertised under OSPF or BGP LAN side routing protocol. So if this 10.10.10x should be reachable to other devices, it should be redistributed. So BGP or OSPF from this service VPN, we do redistribute into OMP, and via OMP it comes to the campus. So you can see it here 10.10.10.x or 0 connected to, for example, the next hop IP address of the home office router. The next hop IP address will become these devices, and vice versa. If this device is introduced with any LAN subnet, for example, here any LAN subnet comes in, so 10.10.20. So again, this is connected through local routing protocol. Irrespective of any routing protocol, we introduce a redistribution. So 10.10.20.0 will be redistributed into OMP. OMP will send it to the home office router. From here, they will be redistributed back into VPNs. Okay, so always LAN side, we enable a routing protocol or static route or the default route. And this LAN side routes will be redistributed into OMP. OMP will be distributing to all the branch routers, all the Vantage routers available inside the fabric. And from here, wherever we have done the reverse redistribution, the routes will be populated. No. This is not part of underlay. Basically, like while you have the home office router, when this is connected to the local transport, this is connected to 4G or connected to MPLS or connected to internet. What transport related configurations you will apply it here? This is part of the underlay. Suppose if this is connected to MPLS, my Vantage router is going to be the customer edge. So for this customer edge, what physical interface, what IP address, what routing protocol towards the MPLS I need to configure. This is the underlay one. Okay, so this is the transport interface and this is underlay configuration. On top of this underlay reachability, we build IP for Vantage, IP for this vSmart. Between source and destination IP address of vSmart and then Vantage's OMP adjacency. OMP will be like source is here and then destination. This is the overlay adjacencies. Overlay OMP adjacency. Over the overlay adjacency, we try to exchange a route coming from here, from this source to this destination, they will be communicated. It goes like this. right? So the first point, what I wanted to cover here is the component, vBond authentication, vManage centralized management, vSmart centralized control plane using OAMP, Vanages basically for a control plane and also the data plane communication. The next topic, what we can see is the deployment. So whether they are deployed in the on-prem or they are deployed in hosted, and what is the initial configurations required and basic configurations to configure them to communicate with each other. Before we go with this controller management, we want to go for a small break. We will plan it and then we will join back. We take about 15 minutes of break and we'll join back. This is 1:15 IST. I think 15 minutes. 1:30 IST. We'll join back.
Okay, thank you.
All right. Okay. Thank you.
Thing various component, vBond, vManage, vSmart manages. Then the second thing, the deployment. So when we go for the deployment, controllers deployment and Vanages deployment. Controllers are virtual machine based. So we don't have any physical support for that. We go with vBond, vManage, vSmart. All of them are virtual machines. And this virtual machine based deployment on hypervisor layer. So either ESXi or KVM. And top of that, virtual machine 1, vBond, virtual machine 2, vManage, and then virtual machines 4, vSmart 1, and then vSmart 2. Or it could be hosted. So we do have Cisco Cloud to host these virtual machines, or even Cisco partners cloud, for example, AWS or Amazon. I mean, we do have Microsoft Azure, so Google. So in these clouds, we can be able to host it. So virtual machines can be deployed, controllers can be deployed and on-prem or on the hosted. When we have an Vanages option, so Vanages, for example, Viptala and then Cisco. So VH100 ISR 1000 for small branch, VH1000 ISR 4000 campus, and VH2000 5000 ASR 1000, and then campus and then data center. So physical appliances from Cisco as well as Viptala. And similarly, we do have virtual x86 platform. So ENCS, on top of ENCS, virtual machine based routers, Vantage devices can be deployed. So VH Cloud. So VH Cloud is Viptala OS based VH router, basically like virtual machine based Viptala router, and then Cisco ISR virtual. So we can introduce virtual machine based ISR or virtual machine based VH Cloud on the ENCS appliances. Or on the private cloud or on the public cloud. So VH Cloud, virtual machine based routers, and then virtual machine based CSR 1000V, and then VH Cloud and then VH CSR 1000V we can deploy. So we have both physical and virtual options. In virtual, VH Cloud and then ISR virtual, and then 1000V we can do it. Okay, so it depends on our choice, like branches and then locations to be introduced with the physical or to be introduced with virtual devices. So the informations like VH 100, 1000, 2000, 5000. So number of physical interfaces and interfaces bandwidth 100 Mbps, 10 Mbps, 1 Gbps, and the connector. So SFEs are RJ45 and the PoE, and again console LT interfaces management port, and plus additional information. So number of LAN interfaces connecting to the LAN side, connecting to the transport, and also connecting over the console and then management, plus the interfaces capabilities. Right. So whenever we deploy the virtual machine, vBond, when this virtual machine is initialized, and this virtual machine is initialized with two NICs. So two virtual network interface card, and these interfaces are placed into two VRF. So we call it as VRF in the name of VPN 0, that is VPN 0 or VRF 0, VPN 512 or VRF 512. In Cisco, we call that as VRF, virtual routing and then forwarding table. But with Viptela OS, they are called as VPN. So VPN is the VRF terminology. So VRF 0 or VPN 0 is created, and then VPN ID with 512 is created. So VPN 512 is basically the management, and VPN 0, this is the VRF for control interface. Basically, this is connecting to the transport. So NIC 0 or at least one interface in VPN 0, which is called as a control interface. Using the control interface, vBound communicates with other controllers. vManage reachability, vSmart reachability, or other vManage's reachability will be provided through VPN 0 interface. So VPN 512, it's OOB access. So management access into vBound, basically like a CLA access into the vBound, and also to verify or to apply all OOB related configurations. So VPN 512 is basically called as OOB interface. VPN 0, basically the VRF for control or the transport communication. So vBound, cloud or on-prem deployment, separate interface for control and management, separate VPNs for control and management, zone-based security is applied. Along with this VPN 0 and then VPN 512, and we apply minimum configuration. Includes system IP address. So unique IP address for the vBound and vBound site ID, just to classify them, an organization name and unique identifier to validate the certificate, and then a vBound IP address. So as I told you, all the devices must reach the vBound, and vBound will authenticate and will authorize them. So even vBound itself authenticate the local device. So vBound IP address, we just introduce a keyword called local. So connectivity information. Connectivity is basically IP, mask, gateway, DNS information for the reachability, system unique IP address for the vBound, site ID for the devices, organization name to validate the certificate, and then vBound and vBound IP address. So this minimal configuration is required so that reachability to vBound gets provided. So vBound, the virtual machine is deployed. When this is deployed, two interfaces, two virtual machine based interfaces are introduced. Each interfaces into a dedicated VPN or VRF. VPN 0 default named as the control, and then VPN 512 is management or OOB dedicated interfaces. So via control interface, vBound reaches to other devices. Along with that, basic configurations about system IP, site ID, organization name, and vBound IP address, we declare it. Any questions here? And same thing we are going to apply for all the other devices. So vSmart, whether we go for cloud or on-prem deployment, we initialize this virtual machine with two NIC and two NICs participating, two dedicated VRF, separate interface and then VPN for control and then management, connectivity, system IP, site ID, organization name, and then vBound IP addresses. So vBound and the system unique IP address, site ID and unique value of it, organization name to trust the incoming digital certificate, and then vBound IP address, fully qualified domain name or the IP address, so that vSmart gets authenticated by the vBound.
So here's basically, okay, the management interface IP is supposed to keep private, right? Because this one is for the management and association to the device. Now, the control side, control interface for vBound is supposed to be fully exposed to internet. I mean, it should have a fully qualified domain name, reachable from any part of a world, right? About vSmart, the control interface, could it be behind the NAT? Could it be in a private space?
It could be private as well as public. But one thing, the private IP address, we configure private IP for vSmart on the control interface. But if NAT is properly configured using NAT IP address, vSmart is able to reach vBond, then session gets established. This is fine. We can do that.
Okay. Okay.
There is a point we talked as vBond, facilitate NAT traversal, whether vManage or vSmart or even Vanages. If any component is behind NAT, both private and then public, so it's vBond's responsibility to collect what is the public IP address to reach the other component, and also if this is configured with NAT, what private IP address has been configured with it. So private or public, then we make sure that the reachable IP addresses between vSmart or the Vantage or the other component with vBond. The same way, when we go with vManage, so vManage is created with the three interfaces. One interface for control to talk with other components, and OOB, VPN 512 management interface, and third interface is initialized as the cluster interface. We don't introduce single vManage inside the fabric. We introduce three vManages or six vManages. So minimum of 3 and maximum of 6, and 3 standby and then 3 active. So this 6 number of vManages we can be able to introduce it. In case more than one vManage introduced, configuration should be in sync with each other. So vManage based cluster needs to be created, and vManage configuration sync happens within the cluster. So for the configuration synchronization, the third interface is introduced. So one interface for control, second interface for management, third interface for the cluster synchronization or config synchronization. With vManage, there's a limitation. All the vManages are in the layer 2 boundary or layer 2 domain. Layer 2 IP based reachability has to be initialized. So vManage to external domain, layer 3 based reachability not supported at this moment. So vManage and maybe active 1, active 2, active 3, we will place the cluster interface on a common LAN subnet, and we'll make sure that they are in sync with the configuration data. So cloud or on-prem deployment, separate interfaces for control management with the VPN, and internal cluster interface for vManage, instance clustering, and similar configuration like connectivity, system IP, site ID, organization name, and then vBond configurations are maintained. Okay, so before I go with the next slide, I just connect with the remote lab. I will show you parallelly. We could see the vManage and vManage CLI, vSmart CLI, vBond CLI, and then Vanages CLI. And this basic configuration and then VPN details, we can cross-check it. So let me connect with the lab. Hope you can see the screen.
Yes.
So we manage dashboard. So we could find one vManage and 2 vBond, 6 Vanages, and then 2 vSmart. The topology what we are going to follow in our lab, you can see this. Okay, so this is the topology. Every pod is going to be vManage 1, vSmart 2, vSmart 3, vSmart 1. So there are 3 vSmart and then 2 vBond. 1 vManage, 2 vBond, 3 vSmart, and then data center with 2 devices on 100 site, and then 2 data center devices, and this is with site 200. So site 100, site 200, and branch 1, branch 2, branch 3, site 10, site 20, and then site 30. So 2 data center and then 3 branches connected through 3 transports. Internet 1 gold transport, internet 2 silver transport, MPLS transport. There are 3 transport, they are connected. So vManage can see 2 vBond and then 3 vSmart and then 2, 2, 4, and then 4. So 8 Vanages. Some of the devices are not updated. We are going to add it inside the fabric. So this is the topology what we are going to follow. And this one vManage, two vBond. So two vManage need to be updated and one vSmart need to be updated. So controllers and vManage devices, you can see it. All the devices console we can launch, maybe on the 15. We can open vSmart 1. So I connected with the vSmart. Now we can give show running configurations. Similar Cisco commands we can use it. Show running configuration. So now we can find the basic configuration under the system. So system and the host name configured as vSmart and then system IP address. So unique IP address for vSmart 172.1.0.16, site ID 1011 and controller group ID, and we could see organization name. So organization name N1 Lab. So this is the keyword which will be used to authenticate the incoming digital certificate. So certificate and certificates parameter called the organization name is compared with locally defined organization name. If certificates organization name, locally configured organization name matches, certificate is validated and certificate is trusted. So we could find the host name, system IP, site ID, and then organization name and vBond. Fully qualified domain name is defined here as vbond.demo.local. And OAMP is enabled and no shutdown state. VPN 0. So this is the control VPN. So under VPN 0, DNS configuration, ETH1 interface is mapped under VPN 0 with public IP address mask and tunnel interface is enabled and there is a default route declared. VPN 512. So VPN 0, VPN 512. So ETH0 and then ETH1. So ETH0 called under VPN 512, ETH1 called under VPN 0 with unique IP addresses. In the same way, I can try with vManage. vManage 1. Admin. Show running configuration. So the same settings we can be able to see it here as well. So host name, system IP, site ID, and organization name locally defined, and then a vBond. And we can find VPN 0 with interface and DNS route, VPN 512, ETH0, and then interface IP configurations. In the same configurations, we can see it for other component. So instead of going to this, I can show one vManage device. Change it. So branch CE3. This is the Cisco device. We use show sd-wan and then running configuration. So this is a keyword we try to use it. So system IP, and site ID, controller group, organization name, and SP organization name of vbound. So vbound.demo.local. Similarly, VRF. So VRF definition. So VRF one. Since it's a Cisco image, we have created VRF1. So we'll go with the configuration for VPN 0 and then VPN 512. Show running configuration, show sd-wan running configuration will come for it. Show sd-wan OMP PS two OMP adjacencies. So the configuration remains the same thing. So we need to give the basic configuration about the system IP address, and site ID configuration, organization name configuration, plus vbound and vbound configuration. So all the devices are initialized with VPN 0, VPN 512, VPN 0 for control communication, VPN 512 for OOB communications. These steps are quite standard. So we obtain documentation software from Cisco website, and we try to import the OVA as the virtual machine. Whether we deploy the vbound or vsmart or vmanage, and the virtual machine will be created. And for the virtual machine, connectivities like VPN 0, VPN 512, IP, gateway, DNS information under the system IP, site ID, organization name, vbound, and NTP configuration. Then we will make sure that this device gets installed with device certificate and also gets updated with the root certificate. If we are not following the external certificate authority, if we follow our enterprise root certificate infrastructure, then obtaining the certificate, device certificate from enterprise CA, and also updating the root CA certificate, we will have to perform that, which is mandatory. We deploy the virtual machine. Virtual machines will not have any default configuration. It will not have inbuilt certificate. So basic initialization configurations we need to update, and similarly certificate procedure we will have to update. Then only the trust and also reachability gets enabled. So initial configuration, system IP address and unique IPv4 address, and logically a VPN 0 loopback interface referred as system gets created on the operating system. Organization name, it's like sd-wan overlay identifier. This organization name basically to authenticate the inbound digital certificate must match on all the components. So site ID identifies logical location of individual nodes. So system IP, organization name, and then site ID values we try to declare for every one component. So deploying vmanage on ESXi. So the basic requirement, number of virtual CPUs, RAM to be, and OS volume, database, number of virtual NICs to be, introduced. Vmanage can manage up to 250 devices, up to 1,000 devices, or 1,001 and more devices. VPN 0 and then VPN 512. What interfaces are mapped as the Ethernet interface for control and then interface for management. So ETH0 and then ETH1, basically like a default VPN, and then ETH1 will be called into VPN 512. By default, vmanage OVA is configured with single interface ETH0. By deploying the virtual machine, additional NIC or additional interface we will have to initialize it. For example, deploying the virtual machine and single interface by default present. We try to add one more interface, and then we will make sure that 2 NIC and 1 NIC to participate with VPN 0, another one to participate with VPN 512.
So do you specify physical NICs over here, or you specify virtual NICs which will be connected to a virtual switch inside the ESXi? So what type of NICs are you specifying here?
This is virtual NIC, but they will be mapped with a physical NIC on the ESXi.
Okay, and in this case, is Ether channeling or supported?
Yeah, sorry, say again.
Is Ether channeling supported? Is channeling of a NIC supported? So, for example, right now you're pointing that to one particular physical NIC, right? If you're saying it's a pass through to the physical interface, the physical NIC. Is bounding, is actually channeling of several NICs supported for one specific connection?
Yes, we can do that. Yeah.
Okay. So for redundancy. Okay.
Yeah, redundancy. Yeah.
Okay, thanks.
Yeah, right. Okay, so we manage initialization. So the default login credential with admin and admin. So this is the first GUI what you can, I mean, first CLA output one is in we manage. Then we manage basic configurations. It's a Viptela OS. So we go to config mode, VPN 512, and then we try to declare the default route. And then interface ETH1 is mapped with VPN 512, IP mask no shutdown, and then VPN 0, similar configurations we do that. Under this system IP, site ID, organization name, VBON, NTP, IP addresses. Then we just use commit to commit the configuration changes. This is like mandatory. So Viptela OS or Cisco iOS. So commit and commit configurations we need to apply. So VPN 0 configuration so that this device can reach other component. VPN 512 or OOB access system configuration. So these three configuration in addition to the certificate infrastructure update is required for every device. Similar settings we will do it for other configurations. So finally, like we manage GUI. So we just log in into the administration settings. Anytime we want to modify the organization name, to add or to modify the VBON, you can do it. In CLI mode also we can change them, or in the GUI also we can be able to change them. It's applicable only for vManage. In the similar process, VBON and number of devices managed, and then number of virtual CPUs required, RAM, and then operating system, number of VNICs we try to initialize it. Normally, WAN edges are configured with additional role of VBONs. There is no dedicated image available for VBONs. We download the image for vEdges, and on top of the vEdges, additional role of VBON will be configured. So that's why you can see here vEdge goes to the configuration mode. System host name is configured as VBON, and system IP, site ID, organization name, VBON IP address local. Commit the changes. Then this is renamed as VBON. So vEdge will be configured with an additional role of VBON. But we don't make any vEdge related configuration. So only like whitelisting of the component plus authentication authorization settings, we try to enable it. The system settings, and along with this interface configuration. ETH0 goes to 512, and gig 0 by 0, gig 0 by 1, 0 by 2 goes to the LAN side. The reason here, controllers will have ETH0 and then ETH1 setting. Since it's a vEdge, ETH0 and then gig LAN side interfaces. So this LAN side interfaces we are trying to introduce it for control communication. So just make sure that what kind of devices are introduced, what interface we are going to introduce it for control communication and for the OOB communication. With VBON, ETH0 is pointing to 512 OOB, gig 0 by 0 interface will be communicating to the VPN 0 control communication. So IP address for gig 0 by 0, IP address for ETH0 512 interface will apply it. And tunnel interface, this is the keyword what we try to introduce at the time of tunneling communication for data plane side. We will discuss about this. So as a basic configurations, we try to introduce VPN 0, VPN 512, and then system. With VBON, so VPN 0 interface is pre-configured. So we introduce a keyword called tunnel interface. If there is a keyword introduced as a tunnel interface, using the tunnel interface, net config or other underlying protocol sessions will be permitted. When vbound is integrated with vmanage establishes the net config session. It's not only with vmanage, like vmanage establishes connection net config session with everyone, because we will push complete configuration from vmanage. So we can disable when it is needed, and once this is connected, we will say like enable the configuration. So disable the tunnel interface configure while performing controller integration. After that, we can enable this. A standard process. We will not do it. So temporarily allow the net config configuration sessions. So VPN 0 with a specific interface, VPN 512 with a specific configuration, system and system specific configurations, we do that. So vmanage establishes net config session with all the other component. So any device configurations to be pushed, vmanage uses the net config underlying protocol session to do that. And vbound VPN 512, similar configuration command eth0 IP and mask, and then the default router declaration. VPN 0, again default route interface and then IP declaration. We can disable the tunnel interface. Then finally, once this is integrated, we can enable that with the tunnel interface. And similar process will be followed for vSmart, and number of devices, virtual CPUs, and then RAM, OS, volume, and number of VNICs to be connected. ETH0 and then ETH1. So ETH0, ETH1. So default and then VPN 512. And VPN 512 interface, VPN 0 interface, IP mask, and then default plus DNS configuration. Then system configuration, system IP, site ID, organization name, vbound, NTP plus commit the configurations. Okay, so vbound, vmanage, vsmart, these three controllers are configured with system settings, VPN 0 settings, VPN 512 settings. Once these configurations are applied, IP-based reachability will be provided between this component. Same logic will be followed for WAN edges as well. When routers are introduced, Cisco C edges or Viptela V edges, they require the VPN 0 configuration, VPN 512 configuration, and system configuration, and the reachability would be provided for the initial communications. Any questions after this?
Yeah, quick question I have. The configuration, I mean netconf configuration from vmanage to all the components, is it going through VPN 0 interface, through the control interface, or through out of band 512 interface?
No, it goes through VPN 0 control interface.
Okay, and if you go back onto slide where you have vbound configuration, right? I might miss this part. Yeah, over here. So you saying here no allow service netconf. Why is that? Because as I understand, this is VPN 0 and we're supposed to have connectivity to vmanage.
This is Cisco's limitation. For the initial time, while we are integrating vbound and vmanage, we disable the net config. Then once the certificate based authentication, validation, everything is done, then again we will have to enable this. We are just temporarily disabling, and once vmanage is integrated, we are enabling to perform the net config session. It's Cisco's limitation.
Okay, and the initial authentication, I mean certificate validation, etc. So it goes through a simple gigabit 00 interface, right? It's not going through the tunnel.
No, it doesn't go through the tunnel. It goes through the standard, the over the transport underlying network.
Sorry, but it's through VPN 0, right? Or VPN 512? From which?
No, they will go through VPN 0. VPN 512 is only for the management access. Apart from that, like no control sessions, no communication takes place.
Okay, I see. So it's initial configuration when netconf is disabled, and once certificates are exchanged and confirmed, when you enable netconf, and it will be used for configuring vBond through the vManage, right?
Exactly. Yeah.
Okay, thank you.
Yeah. So we can see the network settings, vBond, vSmart, vManage with two interfaces, 512 and then VPN 0. So management network reachability and then VPN 0 reachability with this component. Okay, so this is the initial configurations required at the component wise. So any questions in this I will address. If not, then we will start with mutual trust. So the control plane with a mutual trust.
So, if we are going to set up this all things in the lab, like for a like lab session.
Yes, you will do that.
Okay, fine.
So the existing lab I show you, it says one vSmart, one vBond, two vManage, and then two vBond, three vSmart, and then some 8 Vanages. Some of them are not added, so we will add them. But initialization process will be available in the last lab. Installing the VM of vManage, installing the vBond, and then building the initial configuration, assigning the IP addresses, and make up initial login into vManage. So these configurations will be available in the last lab. So both the things, you will do it. All right. So now we talk about integrating controllers. The first step, we do whitelist. So while we are applying the initial configuration on the vManage, while we log in into vManage, it shows only its local information. vManage will not have any visibility to vBond. vManage will not have any visibility to vSmart controller. It shows only the local information. So we will have to whitelist it. So the initialized vBond with system IP or system settings, VPN 0 and then VPN 512 configuration, vSmart with its initial configuration. So we will have to make a whitelisted mutual trust with each other. So we log in into vManage. We manually add all the vBond IP address, vBond login credential, vSmart IP address, and then vSmart login credential, so that vManage will collect all whitelisted vSmart information and then whitelisted vBond information. Once vManage is updated with all controller information, it's vManage responsibility to distribute the controller information with each other. For example, if vSmart is added in the vManage updates the vBond information to vSmart and vice versa. So we are going to add all the controller information in vManage, and vManage distributes updated controller informations with each other. Okay, so we are going to whitelist. So controllers are whitelisted in the vManage, and vManage distributes the information to other things. Then the very important thing is generate CSR. All the controllers are virtual machine based. vManage is a virtual machine. This virtual machine will not have inbuilt device certificate, inbuilt root certificate updated. Similar thing will come for vBond. Same thing will be applicable for vSmart. vBond, vManage, vSmart, they are not having inbuilt certificate, and we have to obtain the certificate for these devices. So for the certificate obtaining process, we will have to generate CSR, certificate signing request, CSR for vManage, CSR for vBond, CSR for vSmart. We have to generate CSR for each and every controller updated on the vManage. Then next step, okay, this certificate signing request will be sent to CA's certificate authority, and then we obtain the digital certificate and we install the certificate for each and every component. So in second step, only the CSRs are generated, and we are going to send the CSR to certificate authorities, and then we obtain the certificate. And once the certificate is obtained, they are going to be installed to every devices. So we generate CSR, we send the CSR to certificate authority, we download the certificate and we install the certificate for vManage, we install the certificate for vBond, we install the certificate for vSmart, and the devices will be ready with its unique device certificate communication. Apart from that, the devices will form the mutual trust with each other, whether they want to make a control plane tunneling with OMP or whatever it may be, or data plane communication between WAN edge to WAN edge, whatever may be, they try to establish it. So configuring the tunnel interface and establishing the control plane connections with each other will take it place. And additionally, we will install the license file. So the point what I mentioned, try to minute here, we are trying to whitelist the controllers, and for the controllers, we will generate the CSR by uploading the CSR to CA and obtaining the certificate for each component. We will install the certificate to the devices. Using this device certificate, the devices will be ready for mutual trust to get established inside the fabric. Okay, so adding the devices entry manually and registering or initializing the CSR and installing the certificate is a mandatory process as part of the whitelisting. Any question in this place?
The whitelisting, is it the system IP system IP should be used, or VPN 0 IP address should be used? Which one?
Okay, it is a reachable IP address over the transport, VPN 0. We don't use system IP address for this.
Okay. And vManage, could it act as a certificate authority, or we totally relying on separate structure like Active Directories or IC?
Yeah. So vManage can act as certificate authority, but it cannot generate or it cannot sign certificate for the controllers. It can sign certificate only for the WANages, virtual machine based WIPT alarm routers, or virtual machine based Cisco routers, or even any Cisco router is not with inbuilt certificate. Only for the WANage routers, vManage can issue the certificate. vManage cannot issue certificate for the controllers. It's supposed to be an external certificate authority. So we can go with Symantec, or we can go with even enterprise certificate authority, or any CA or any external CA we are supposed to reach.
Mm-hmm. Okay, thank you.
Okay, so this point, I'm just talking about only the controllers. So vManage, in vManage, controllers are whitelisted. Since controllers are virtual machine based, every controller's CSR we do generate through vManage, and then by sending and receiving the certificate, installing the certificate, and all the controllers will be ready with mutual trust. Same thing we need to consider for the WANages. Okay, before we see the WANages, adding the controllers to vManage. On the vManage, under the configuration, you do see an whitelisted tab. I can show you directly. What I can do here is I go to vManage. So under vManage, we go to the configuration and then devices. So in devices, this is controllers whitelisting, WANage list. This is WANages whitelisting. So these all are the WANages permitted in this fabric. Similarly, controllers. So they have added vManage 1, vSmart 1, vSmart 2, vBond 1, vBond 2. So the whitelisted controllers. To add them, we just choose vSmart. And then vSmart.
But it has a system, sorry, but it has a system IP. It's not reachability IP, it's a system IP, right? Which is used.
No, it's a reachable IP address. So once the reachable IP address and username password is provided, and vManage collects these details. These are the collected information about this vManage. vManage
okay.
configured with system IP, site ID. This is in the local CLI mode, and the device synchronization for net config in sync, and then certificate status. This is collected information about it.
Okay, thank you. Sorry.
Okay, so the similar process we can be able to add for vBond. So vBonds and vBond management IP, and then we could find the username and then password. So whitelisting of this component, maybe the controller handled this. So Vanage's whitelisting, we can have a file called Vanage list file. This is the file which we can download it from Cisco, or which can download it from Webteller. Once this is uploaded, it says permitted chassis IDs and then associated certificates serial number. So we can find the device model, chassis ID permitted, and then certificate serial numbers. Okay, so controller are whitelisted, and then Vanage lists are whitelisted. Once they are whitelisted, we can generate CSR, and we can install the certificate for them. For that, we go to the configuration tab. Under these certificates, so we can choose the controllers. So let's say vSmart. Now they are all updated. If they're not updated, you can say like certificate status. Okay, so certificate status will not be available. So what you can do is you can choose any of the device and view CSR, generate CSR. If the CSR not generated, like you can say generate CSR, and then copy the CSR, and you can send it to certificate authority as a standard process. And once a CSR is signed by the CA, and download the certificate, keep it on the desktop, and install certificate, and then we can choose a file like what certificate we are going to initialize it. So at this moment, I don't have any configuration files here, but while you are doing the lab, you will do the lab exercises. So like generating the CSR and sending the CSR to CE and downloading the certificate, installing the certificate. This process, you will try to do that. But it is a place like you can see vSmart1 generating CSR, uploading the CSR, and then you can send them to the CA, install the certificate like vSmart and then vBond. All the controllers CSR generation, installing the certificate, you can perform it in this case. So make sure that all the devices are installed with its unique device certificate. So certificate serial numbers are updated in this place. Okay. So controllers are deployed as a virtual machine. Virtual machines VPN 0, virtual machines VPN 512, virtual machine system configurations are locally applied, virtual machines device certificate, and virtual machines root certificate to be updated. So they can be updated through vManage. So basically through vManage, using the certificate configuration tab, we can do it. If not, Cisco has given another option. We can log in into this controller CLI. Using CLI commands, the certificate installation and root certificate update, we can perform that. So we can CLI to each and every devices independently, and from this local configuration board, certificate gets updated. Either way, like we can be able to do our specific task. All right, any questions in this place? So controllers and then controllers readiness for mutual trust. All right, then Vanages and Vanages whitelisting. Vanage and controllers whitelist. So administrator defined controllers. So as I told you, so we just whitelist all the controllers in vManage. Once this is whitelisted, vManage pushes the permitted controller information to vBond and then vSmart. Same way, Vanage list. So signed Vanage list. The file is uploaded into vManage. All whitelisted Vanage informations will be distributed to controllers like vBond and vSmart. So administrator defined controllers and administrator uploaded Vanage list, whitelisted. And this is distributed by vManage to all the controllers. So we go to vBond. Though we have not made any local configuration, like whitelisted controllers and then whitelisted Vanage's information, we can see. With vSmart, whitelisted controllers and then whitelisted Vanage information, we can find it. In vManage, whitelisted controllers and then whitelisted managers we can see here. So all the controllers will sync with the whitelisted controllers and then whitelisted manage informations.
Who should be signing 1H whitelist?
Okay, so this file is created by Cisco or this file is created by Viptela. So while we are purchasing sd-wan solution from Cisco or Viptela, and Cisco or Viptela will give us this file, or we can log in into our customer portal, we can download this file. Okay, this file can be edited or can be updated only by Cisco or Viptela. So this is to control the licensing behavior across the fabric. In the sense, like if we have purchased 10 Vanages, then Cisco will include 10 chassis IDs or 10 devices entry in this file. In future, we try to include or update 5 more devices. So 15 devices we have purchased. So Cisco updates 5 more devices entry and they will ship the file. In any manner, we try to include our own chassis ID. We try to update this file, which we are not allowed. So like number of more devices inside the fabric to be operated, we wanted to increase in our own, not permitted.
Okay, so
yeah, go ahead.
Okay, so in case, for example, RMA required for the VH, right? So the chassis ID would be changed. So how handle this hardware replacement of VH?
Okay, so in this case, the complete process should come from Cisco. Like the device, anyway, we have to purchase the hardware, right? So we have purchased a device number 1, and we are going to decommission, and that is going to be commissioned with a new device. Obviously, this new device should be authorized by Cisco. That means you have to buy a new Cisco device, or you have to use a Cisco device. You have to communicate them that this chassis ID is getting migrated. It's moving from older device into new device.
Okay. Yeah, so for RMA, it's basically hardware replacements, right? So nothing is additional to be purchased. But the way how I hear it, before doing replacement, Cisco needs to provide a new signed list. This list needs to be installed to vManage, pushed to vSmart and vBond, and only after that replacement could be taking place.
Yes, we will have to decommission it. There are some small things we need to check in. If we have purchased a router with inbuilt certificate, so commissioning and decommissioning of the device, it's completely like we need to completely decommission the device. We have to depend on Cisco to provide a new device, and they have to update the Vantage list file. Then we will have to introduce commission into our fabric. Then second option, if the device is not with inbuilt certificate, so what we can do is there is an file like Vantage list is updated. There's a chassis ID. So that existing chassis ID we can decommission for the older device. Same chassis ID we can be able to allocate it for the existing or the new devices. So there are options available. It depends upon the hardware and then what kind of device we try to introduce, we can do it.
Okay, so it's the bottom line. It's not simple hardware replacement. It's some provisioning has to happen first on the controller before the actual physical replacement taking place.
Yeah, because the device is in the fabric commission in the sense like this is trusted and OAMP session is created and certificates are populated and all device specific configurations are uploaded. So we will have to take all the configurations back. So while we are decommissioning all the existing configuration to the devices using system IDs or template mapped or the certificate mapped, everything gets removed from the vManage perspective. Then the device is completely decommissioned, commission a new device and existing configuration you can apply. So the decommissioned device, similar information, similar configurations will be applied for the newly added device.
Okay, thank you.
This is not only applicable with sd-wan, this is applicable to SDA and this is applicable to even ACIs. So because the configurations or the policies are stored centrally on the controller. So we manage. So the place where we are applying the configuration, so that device is programmed based on that and it is participating inside the fabric. Whenever it's not required, decommission it make the device with the default settings, and then commission a new device. Same configurations we can restore it. Any other questions apart from this? Okay, so control plane whitelisting. So administrator adds controllers in the vManage GUI. vBond, the controller type, and then hostname collected information. Automated certificate signing through DigiCert, and controller list is distributed by vManage to all the controllers. So controller's identity. So as a default behavior, so device certificate, each controller is required with its device certificate. vBond, vManage, vSmart, they are required with to have its unique device certificate, and also the root certificate. So DigiCert root chain, AveNet root chain, and then Cisco root chain, WebAlarm root chain. So you can find like it has DigiCert, AveNet, Cisco, WebAlarm. So multiple CA root certificates are in the root chain. The reason WebAlarm, so WebAlarm root chain. So this is like if the WAN edges or if any router has the certificate signed by vManage. So in a situation that routers are taking the certificate from vManage to trust, again, WebAlarm root chain. So to trust Cisco CEdges, Cisco root certificate. Then to trust WebAlarm devices, again vEdges. Again to trust other controllers, again DigiCert. So this trust can be from any manner. So it depends on the situation. We will have to update our root certificate. So controllers will have its unique device certificate. In this example, these controllers are owning the device certificate from DigiCert. So to trust other controller, DigiCert root chain. So to trust Cisco CEdges, to trust WebAlarm vEdges, to trust the vEdges or CEdges with no certificate, and the certificate generated by vManage, then WebAlarm certificate. So again, root certificate chain gets updated.
Sorry, I do have a question. Sorry, probably I have so many questions so far. Look, in the case when the root certificate, CA certificate is getting expired, right, and the new one has to be installed, let's say for Cisco, for VIPTEL, or whatever, right? Does it mean that underlying certificates to the devices has to be renewed? So new CSR has to be created and new certificate has to be uploaded down to the chain. Is that the case? Or?
Yeah, that's more than enough. Even what Cisco has automated, in case vBond or vSmart root certificates are about to expire, or device certificates are about to expire, and this renewal process we can automate through vManage. So we get a notification through vManage, and through vManage we can say this is the updated root certificate or updated device certificate we can install to the component like vBond or to vSmart devices.
Okay, so once you have a new root certificate, let's say for Cisco signing authority for CA, right? Once you install it into vManage,
exactly, vManage replicates immediately to other vBonds and then to vSmart devices. You're right.
It's replicating or will be resigning because
the technical term is resigning, that is getting updated.
Okay. Well, still the question, right? Because vManage is actually making the certificates for VH devices, right? And those has to be signed by the root certificate. Am I correct?
Yeah, you are right. So when vManage is distributing the certificate for vanages, again, it's a manual process. Like vManage root certificate itself to be updated. So we download a certificate and then we do it. Since this is within the fabric, Cisco doesn't want like you download vManage root certificate and then install to vManage, install to vBond, install to vSmart. This is not needed. So once you go with vManage based certificate for the edges, and this vManage self-signed root certificate is automatically updated. Only for external CA, we will have to update the root certificate. I hope you got the answer.
Right, but the thing is that, again, back to my question, I'm sorry, but I wanted to be very specific to that. If a root certificate, because we have seen it in the past, when root certificate actually expiring, right, and you request and you getting, you installing the new root authority certificate, right? All dependent certificates which vManage would be distributing to vBond, to whatever, and would be signing with this root authority certificate. Other certificates would be reissued, or it's manual process to reissue it?
Okay, for vBond and vSmart, for the controllers, this is automated. Once you install the certificate, once you update the certificate, once you renew the certificate in vManage, and vManage renews to all the controllers. But for the WAN edges, manually we will have to do.
Okay, but for the V edges, you told that it would be a local signed certificate from vManage. So it would be only the case when vManage local signed certificate is about to expire. So in this case, you need to create a new one and manually distribute, well, create signed request for the VHs, as I understood.
Oh, no, not like this. Suppose if a VH is taking a certificate from vManage, if the certificate is about to expire, obviously like vManage renews a certificate automatically. So certificate process inside the vManage architecture is automatic. In case a VH is taken the certificate from external CA or enterprise CA, if this certificate or the root certificate is about to expire, then manually we will have to do that.
Okay. So local signed would be automatically done, but if you're using enterprise or whatever external CA, in this case, you need to manually, well, renew this root certificate and afterwards manually refresh certificates on VHs.
Exactly. Yeah. Right.
Okay. Okay. Yeah. Thank you. Sorry for stealing some time.
That's okay. Others, any questions? Akhil, Piyush, Sachin, Isram, Vipin?
No, from my side.
Okay. Hope you can be able to follow.
I think most of the questions are asked by Sergey, so.
Okay, great then, yeah. Right. So this is controller's certificate, and we go with router's certificate. Okay, remember V edges and then C edges. So VH router identity. So VH routers, they do have inbuilt device certificate. So during the manufacturing, okay, we do have certificate installed. So the device certificate is installed locally on the devices. So from the Viptela software, they do have the root certificate. So VH Viptela router device certificate, but signed by AVNet CA, and then root certificate, again a digit from the software. So keep this information. If we try to introduce a VH router inside the fabric, this VH routers are having the device certificate signed by AVNet. Same behavior when we go with VH appliances. These appliances are very old devices. Nowadays, we don't see VH appliances, only VH routers we do see. So VH appliances, device certificate from AVNet, and then root certificate from Symantec. So each physical VH router is uniquely identified by the chassis ID and certificate serial number. And this chassis ID and then serial number of the certificate. Basically, the certificate is stored in onboard tamper-proof module, TPM module, so installed during the manufacturing process. So each physical appliance or physical router of VH installed with an inbuilt certificate, and this is signed by AIMNet. Depends on the image version, Symantec root CA or DigiCert root CA certificate gets updated. These all are inbuilt and available from the software. Now, when we go with the Cisco boxes, so Cisco routers identity. So with SUDI, this is equivalent memory like a TPM. So Cisco routers with the inbuilt memory. So they do have the device certificate. So inbuilt certificate, and the inbuilt certificate is signed by Cisco. So Cisco routers or CH routers are having inbuilt certificate signed by Cisco itself. Viptela devices signed by AIMNet. And some of the devices, like some of the Cisco routers without SUDI, is nothing but they don't have inbuilt memory, in the sense they don't have inbuilt certificate. If there is a Cisco edge router, C-edge router with no SUDI, in the sense like if there is no inbuilt certificate, then we have to obtain the certificate for this. We have two options. Cisco C-edges can obtain the certificate from vManage. vManage itself can act as certificate authority, and vManage can issue the certificate to Cisco devices. Or V-edges, with Cisco devices, C-edges can talk to external certificate authority or the enterprise CA. From them, they can take their own certificate. But as a standard design, it's customized choice. WAN edges, Cisco devices are going to take the certificate from vManage, or they are going to take the certificate from enterprise CA itself. So device certificate, own identity, it is from Viptela or from external certificate authority, and from the software DigiCert root certificate. And then Viptela devices, these are all virtual machine based. Virtual machine based VH cloud, virtual machine based ISR virtual, virtual machine based CSR 1000. These are virtual machine. Virtual machines will not have inbuilt certificate. So this virtual machine needs to be installed with a certificate. Again, there's an option. So this virtual machine based router can reach to vManage to obtain the device certificate, or this virtual machines can external certificate to obtain their device certificate. Okay, so the thing is very clear. So when we go with Viptela routers inbuilt device certificate signed by AIMNet, Cisco routers with inbuilt certificate, and that is signed by Cisco. And apart from that, Cisco devices with no inbuilt certificate or virtual machine based Cisco or Viptela devices, they need their device certificate. They can obtain the certificate either from vManage or from the external certificate authority. Okay, hope this is clear. Any questions on this?
So means without certificate, it's not going to be like work, correct? Anyway, we require certificate.
Yeah, this is mandatory. With Viptela, this is mandatory. So any component to communicate, like it may be whatever it may be a controller like vManage or vBond or vSmart or Vantage. So they need all these configurations. So they need to have VPN 0, at least one interface. So with IP, and then mask, then gateway, and then DNS information. Okay, DNS is optional. Then VPN 512. Even Cisco says VPN 512 is not mandatory, because VPN 512 is only for the reachabilities. But as a standard process, we can do that. But VPN 0 is mandatory. And similarly, system configuration. So while we are configuring the system, and inside that, we need to give the system IP address. Without system IP, no device is identified. So system IP address is mandatory. And then site ID is mandatory. And then vBond IP address or fully qualified domain name is mandatory. Organization name to trust the certificate is mandatory. Okay, so system and then system specific configurations, we need to initialize it. And then fourth step, they should have the device certificate. And then they should be updated with root certificate. So if these configurations are in place, then this device, this component will participate in the fabric. If not, they will not participate. If VPN 0 is not there, then layer 3 for underlay and then overlay reachability cannot be established. If system configurations are not there, then devices cannot be identified. If device certificate or root certificate are not there, then mutual trust control plane session cannot be established. So you have to make sure VPN 0, system, and then device certificate, root certificate update for every component. Then they will talk with each other.
Okay, and for that IP, we can assign from our DSCP info server or info blocks, or it is like an integrated solution with this SD-WAN for that management.
Okay, basically this is an IP addressing procedure. The interface can take IP using static mechanism or using DHCP. That doesn't matter, but the interface should take its own IP address to have a reachability to the component.
Okay, fine. Thank you.
So VPN 0 IP address could be dynamically assigned, right? But it's first of all, it has to be whitelisted on an initial, let's say, onboarding, right? But a system actually getting recognized by system IP, and this is act as a loopback IP address.
Yeah. So while we are trying to whitelist it, so whitelisting is based on the chassis ID. So we don't follow the IP address based whitelisting, and then certificate serial number, certificate serial using this, and then locally configured organization name. So this is the parameters are used for whitelisting and also to trust the certificate. So chassis ID and then certificate serial number. This is applicable for WAN edges because Cisco generates the chassis ID and then imposes on the hardware and then applied. But when it comes to controller and the chassis IDs are dynamically generated and certificates are not present. So what the design here is, we are just manually whitelisting using the IP address. We establish the sessions manually, like go to vmanage using the control IP address using login credential. Vmanage will talk to the controller, collect all the information. Then based on the collected information, it recognizes internally.
Okay. Yeah, thanks.
All right, I go to the next slide. Okay, so there's a simple process we always to remember. VH Cloud Router Identity, or the router which has no inbuilt certificate. So how they obtain certificate from vmanage? So the first thing what we need to understand here is OTP or token generated by vmanage. So as I told you, we will whitelist the WAN edges. While the WAN edge list is uploaded on the vmanage verifies the WAN edge list file. In that, any chassis ID is added with certificate serial number. It's nothing but when Cisco CH is updated, this is the CH chassis ID, and this chassis ID is mapped with this inbuilt Cisco certificate serial number. So if the file or if the list is available with any chassis ID and the serial number of the certificate, vmanage recognizes it's an inbuilt device. For example, the chassis ID and then along with the certificate serial number. If there is a chassis ID not included with serial number, meaning that this is not a physical one, it can be a virtual one. So this chassis ID can be mapped to a virtual machine based VH Cloud or ISR virtual or CSR virtual. In this case, a token will be generated. That means a temporary ID or OTP will be presented. So vmanage looks into VH list file. If the physical boxes with inbuilt certificate, chassis ID and then serial numbers are updated. If not, for every chassis ID, an OTP would be generated. It's a simple understanding. So this chassis IDs are dedicatedly available on a hardware, and this chassis IDs dynamically distributed to any virtual machine based or any physical appliances we try to introduce inside that. Whenever we are trying to do that, we'll just apply this token value so that By validating the token, the component gets registered. Okay, so OTP or token is generated by vmanage, and this is generated at the time of uploading the VH list file. So now what we will do, we will install or we will initialize a VM, and this VM will be with its locally generated chassis ID. We remove the chassis ID, and whatever the chassis ID is present on the file, this chassis ID and then associated OTP, these two chassis informations we try to collect it, and we will enable it for the Vantage devices. So when the Vantage is enabled with the new chassis ID and the new OTP, and by validating the OTP, vManage will understand this chassis ID needs to be activated. So by validating the OTP, so a new device or new chassis ID will be applied for the component. So like what I can show you here is, I go back to an old plain one. I try to take one router. I'll take one device. Then I try to take and vManage. So this is the VH. And then I do have vManage. Okay, so now we have Vantage list file. So now here we included 1111 and then the certificate number, for example, 0001. So just understand this is the chassis ID and this is the certificate serial number. And 1112, then we do see an OTP. So maybe like 0001101 like this. Okay, so now when this is uploaded, like when this information is updated, so vManage will understand this is the certificate available, and this certificate is mapped to this chassis IDs. So we can introduce a router here, and this router can be with this inbuilt values. So it's like 1111 is a chassis ID, and then 0001 is the certificate serial number. Okay. Now when this virtual machine based VH is initialized, now this is generating local value. For example, 5678 is a locally generated chassis ID, and then certificate is not present. Certificate is not present. So now what happened, using this chassis ID, if this is registered with the vManage, it says it's not whitelisted. So now what we try to do, we try to make sure that we are not using the locally generated chassis ID. Instead, vManage uploaded chassis ID and then vManage uploaded or vManage generated OTP. So these two values we copy and then we try to enable on the Vantage. So manually we log in into VH. We say that try to use the chassis ID of 1112 and then try to use the OTP value for this one as 1101. So VH takes this chassis ID and then uses this OTP, and using these two values, Vanages will talk to vManage and then vManage will issue a self-signed certificate for it. So by carrying this to information to vManage, vManage will understand that this is the chassis ID and this is the OTP, and this is applied to a specific Vantage devices. By validating them, it issues a self-signed certificate. Once this is issued the certificate and this OTP is removed, and serial number for the certificate gets updated. Now this is generated with a new certificate like 88 and then 99, and this is mapped inside the file. And this is updated. Chassis ID is 1112, updated with the certificate serial number of 88 and then 99. Okay, so the Vanages which have no inbuilt certificate or the Vanages which have no device certificate, and they copy the chassis ID and associated OTP which is available from vManage, and based on the chassis ID and then OTP, they will request the vManage to activate. After the activation of this chassis ID, and a new certificate will be provided by vManage itself. So we just try to upload the Vantage list file. For all unclaimed chassis IDs, which is not mapped the serial number of the certificate, OTP or token is generated. We copy the chassis ID, we copy the OTP from vManage, we go to the manage devices, we apply these values to activate these component. So this is how we will apply the chassis and associated certificate serial number, which is self-signed by vManage in the sd-wan fabric. Any questions or any clarification in this place? Yes, so you can see like token generated we manage, and OTP token is supplied to VH Cloud and in the VM deployment. It could be an automated process, or manually we copy the chassis ID and then OTP in VH Cloud and we register it. So vManage issues self-signed certificate to VH Cloud post OTP token validation, and once the certificate is issued, then OTP is removed, and then root certificate is updated using the software or whatever it may be, the manual process we try to introduce it. So WebTeller devices with inbuilt AVNet certificate, Cisco devices with inbuilt Cisco certificate, Cisco or WebTeller devices which requires the certificate from vManage. They copy the chassis ID associated OTP from vManage by using the chassis ID and then OTP. Then vManage validation that, and then issued certificate, self-signed certificate will be issued for these devices. So this process will be available in our lab exercises, but just to understand the lab exercises configuration, you can tell that, so this is how the devices with no inbuilt certificate obtains a certificate from vManage. So I can give a quick information here. So I can go back to the configuration and then devices. This is whitelisted controllers and then whitelisted advantages. So now you can find some of the chassis IDs are with serial number of the certificate and some of them are with token generated. So VH Cloud, there is a chassis ID generated and there is a token. So we can deploy a VH Cloud virtual machine based router, and on the router we use this chassis ID and then this token. So this VH Cloud router reaches the vManage. After activating this chassis ID, issuing the self-signed certificate, this token will be updated with a certificate and associated serial number. So CSR 1000V 1, 2, 3, 4, 5, 6. There are 6,000V routers are obtained with the certificate, and this is managed from Cisco. That's why you can see a serial number of it. Apart from that, VH Cloud, all VH Cloud routers are generated with just chassis ID and then associated token values. So these 32 chassis IDs are licensed from Cisco. So this company, like Entron organization, purchased 32 Vanages to be introduced. Out of 32 virtual machine based Vanages, like none of them are physical, all of them are virtual. So they generated 32 chassis IDs, and we manage associated serial number and then token value inside the database. So the command, even you want me to show, I can give at this moment. You will be doing in your lab, but still you can activate them. Branch C3. Request platform, and then VH software activate. System, and then you can have these options. System sd-wan, VH Cloud, activate, and then chassis ID, chassis number. We will copy this chassis number, some values here, then the respective token. So once we give the chassis number and then token, which is copied from vManage. So using this chassis ID and then token, this branch CE3 will be activated. So then vManage will issue a self-signed certificate for these devices. So it's a manual process obtaining the device certificate for the vManage devices which are not available with inbuilt certificate. All right, so we can see some values here. VPN 0, more than one interfaces could be placed, and we do have IP configuration plus tunnel interface and then tunnel interface associated configuration, encapsulation, what tunnel we are going to build it, and each transport is with its unique tagging called color. So color MPLS and then color based internet, then default route configurations. Yes, the process of CSR2 certificate, every device, router or the controller will generate the public and then private key pair. So private and then public keys are generated on the vEdge router. So public key is sent via certificate signing request to the certificate authority, and certificate authority signs the certificate CSR and then returns the certificate. And then certificate is loaded into TPM chip and which is present. Then vEdge router has the root certificate which is updated through the software. Same process, we will go for the controllers, vSmart, vBond, vManage. This component generate their own public key and then private key, and public key is sent through the CSR to the certificate authority which is signed, and the signed certificate is installed back into these devices, and then root certificate gets updated. Okay. So now we believe that controllers, vAnages, maybe vEdges or cEdges or virtual machine based devices, they do have their unique certificate. So how they built the mutual trust with each other. So just to build the mutual trust, vBond validates certain parameter. vSmart, vManage, and vAnages will validate some parameters. vBond validates root of the trust for the certificate. So root certificate chain is verified. Certificate serial number is verified against the whitelisted entry and organization name. So certificate chassis ID serial number and certificate organization name is validated by vBond. Similar way, vSmart, vManage, vAnages, they will validate the certificate trust. Similar way like organization name against the locally configured one. So organization name under the system we do define, and this is validated by this component. So everybody will validate the certificate. Like it's a mutual validation. vBond also validates. Again, vSmart, vAnage, and then vManage. These components also, they do validate it. So vSmart to vSmart, vManage to vSmart. So same process like a trust for the certificate, certificate serial number as well as organization name. Certificate serial number and then organization name. So the components will validate the parameters. So vSmart and then vManage trust, again certificate serial number and then organization name, and vAnage again trust, organization name, certificate serial numbers. Okay, so now we will put the things in one place. We do have vSmart, vManage, vBond, vAnage devices. At vAnage perspective, certificates are exchanged and mutual authentication takes place between vBond and vAnage. So as you are familiar, so we just take an example, vAnages, AveNet certificate, vBond, the Symantec certificate. So controller certificate and then vAnage certificate. Now vBond validate vEdge router serial number and chassis ID against authorized vAnage list, whitelist. And similar way, organization name of the vBond certificate is validated. So vEdge router validates vBond certificate's organization name against the locally configured one. Once certificates are validated, then DTLS tunnel is established. This is called as secure channel. DTLS is UDP based, TLS is TCP based. It depends on the situation, TCP or UDP based. But always between VBON and WAN edges, it's DTLS, that is UDP based session. It's a temporary session, and this DTLS UDP based channel will be created. The provisional DTLS channel is established between VBON and WAN edges. So additional information. So it's VBON's responsibility to distribute all the other controller information available vmanage, available vsmart. All vsmart and vmanage controller informations will be distributed to vh over the DTLS. Similarly, vBON notifies vsmart and vmanage about the vanage, the router information. So the router public IP address, associated, private, whatever the system information is collected through this authentication process. Then provisional DTLS and then DTLS, the temporary tunnel, is terminated. So like WAN edges gets authenticated. So WAN edges share the certificate, and then VBON shares the certificate. By validating the certificate, a DTLS, a control plane tunnel, you can say like this is the control tunnel. A control plane tunnel is established. Over the control plane tunnel, this router informations will be distributed to vSmart, and the controller informations will be provided to WAN edge devices. Once the mutual informations are communicated, then tunnel will be terminated. As a standard process, the WAN edge will be ready to talk with vmanage and the other vSmart devices. Any question in this place? Fine. Then I'll go to the next step. In the next step, WAN edge collected the IP of vmanage, collected the IP of vSmart by VBON DTLS session. Similar process will be followed. In SD-WAN, every component gets authenticated by all the other components. So WAN edges authenticated by VBON, WAN edges authenticated by vmanage, WAN edges authenticated by vSmart, and vice versa. So certificates are exchanged and mutual authentication takes place between vSmart, vmanage, and vEdge. So vEdge sends the AIMNet certificate, vmanage gives the Symantec certificate. Same process with vSmart. Then validation. So vSmart and then vmanage, they validate the chassis ID and then the serial number against the whitelisted database. And organization name is validated in the vanage. And once they are validated, it's a permanent session. With VBON, it's temporary, but with vmanage or with vSmart, it's a permanent session. Permanent UDP based or permanent TCP based DTLS and then TLS tunnel. And inside the tunnel, the underlying other protocol communication takes place. So what I mean to say here, once this mutual trust is established between vmanage to vanage, there is an underlying protocol session. With vSmart and vanage, there is an underlying session. So this underlying session is called net config session. Net config session, so that any configuration, if this vanage needs to be pushed, vmanage will send it. And vSmart and then vanage, this is basically the OMP session, the routing protocol adjacencies. So certificates are communicated, certificates are validated, mutual trust is built, tunnel gets established. Inside the tunnel, net config communication or OMP communication gets initialized. And this session is permanent. If I go to vanage or vSmart or vmanage, show control connection, we can say there is a net config DTLS, again OMP routing protocol adjacency. Over the details we can be able to see it. Okay, so WAN edges authenticated by VBON, WAN edges authenticated by vmanage, WAN edges authenticated by vSmart, and with vmanage underlying protocol session, with vSmart OMP underlying protocol sessions. Any questions in this place? So you can see all the information in one place. So in step 1, Vantage with VBond authentication. So Vantage and then VBond exchanges the digital certificate and validating the chassis ID, serial number, organization name. Certificates are trusted, and then DTLS session gets enabled, and VBond, okay, exchanges vSmart and then vManage information to Vanages and Vanage information to controllers. Then Vanage communicates with the vManage, certificate exchange, DTLS session, then net config session, and using the net config session, like full configuration file of VH, like full configuration file using template. In vManage, if we have defined template, so template is a place all device configurations are applied. If there is a device template mapped to this chassis ID, all device configuration will be enforced by vManage to Vantage through the net config. And then device is with complete configuration. Then Vanages will talk to vSmart, certificate exchange, authentication, DTLS, establishes OMP, and through OMP, all routing table and then routing information, routing updates will be communicated. So using the routing update, T-log, all the Vanages transport, IP transport information, and the service VPN entries, VPN keys, everything gets communicated through OMP, then routed to router, Vantage, for example, VPN tunnel gets established. So once OMP session is successful, router to router, IPsec tunnel is built, and IPsec tunnel is ready for data plane communication. Just to check the quality of this tunnel and then tunnel liveliness, BFT session is initialized or the VPN tunnel, and then router to router. Each IPsec tunnel will be with its unique BFT, bi-directional forwarding reduction sessions. Okay, so 4 steps of fabric initialization or fabric communication with these boxes. So VBond to Vantage, Vantage to vManage, and then Vantage to vSmart, Vantage to Vantage communication. Any questions in this place?
No, thank you.
So from here, can you come on the last slide?
Yeah, sure.
So initially, the new device VH is communicate to VBond, correct?
Yes. Okay, so this is the place we try to make our configuration.
Yes, VBond assign the IP, means share the IP of vSmart and vManage to VH.
Yeah, so
it will make a VPN 0 at that time.
Yeah, sorry, come again.
So at that time, that connectivity in between through the VPN 0 or VPN 512. That is, I think initially it will comes through
VPN 0. VPN 0. Okay, remember we VPN 0 with the IP system specific information, HTTP with the certificate and then root certificate. Same with VBond is also needed with its config VPN 0 and then system configuration and then certificate plus root certificate. Okay, along with that, system have additional information whitelist this. Okay, it is whitelisted entry. For example, chassis ID should be there plus the associated serial number of the certificate. This is supposed to be present.
So whatever I understand this, I try to explain, and if I'm wrong, just guide me once again. So okay. That IP address now, this VH have the IP address of vManage and vSmart, and there is a connection established in between. Now vManage give the configuration file to the VH new device in this second step. Correct. So it will download all the configuration. It will go for the in the next step. It will communicate with the vSmart for OMP session and establishment.
Yeah, that's right.
Okay, in last my VH is ready after taking all configuration from vSmart and vManage. Now I can control and I can change the configuration through vManage. The role of vSmart is over.
Okay, this is not the third step is not configuration. It's a control plane live updates like routing protocol, OMP, neighborship, and via routing protocol, number of VPNs available, routes from one VPN to another VPN, okay, and any policies to be communicated. This is the routing and routing behavior decision inside the fabric. The third
Okay.
step.
Okay, fine.
Okay.
Okay, well, actually, I do have a question, as usual. Look, who is driving connection? Who is initiating connection on each step? So, for example, on step 1, it's VH is trying to reach vBond, right, and setting up a connection to vBond, right?
That's right.
On the second step, when vBond, well, actually, on the first step, vBond is updating information of a new VH to vSmart and vManage. So when we go into the next step, who is initiating connection? VH or
VH, yeah. VH. Every time the VH initiates the connection. So vBond, vManage, vSmart, they never initiate any connections.
Oh, okay. So if VH is actually disappears from network, no one actually tries to ping it, or no one tries to reach it.
Okay, then control plane session will be down. Control connections are down, and you can see a notification inside the fabric. I mean, if you go to the GUI of vManage, it says control connections down.
Okay. Is there any mechanism which just tries to re-establish connectivity? Or it would be totally driven from the VH side?
Okay, if the control connections are down, there are two reasons. One is the IP reachability. So maybe VH failed to reach vManage, or VH failed to reach vSmart. Maybe TCP, UDP port block on the firewall, or IP reachability or transport reachability. So due to some reason, vManage to Vantage or vSmart to Vantage, the TCP, UDP or IP reachability is not there. We will have to troubleshoot. Then second thing, certificate. Vantage, whatever the certificate is available, may not be trusted in vManage, or vManage may not trust the Vantage list certificate. So certificate, device certificate, or device root certificate information, that's something to be troubleshooted. These are two reasons why the control plane is going to go down.
Yeah, that's fine. But I mean, try to imagine this scenario that a connection from VH to whatever, vManage, for example, right? Or vSmart, to vSmart, getting interrupted. So, for example, I don't know, internet connectivity broke down. When it's restored, and but I mean, no VH, no link flap is seen on VH side, or physical link flap is seen on neither side. So who will be trying to establish connection?
Vantage, always Vantage.
Okay, always VH. Okay.
Yeah, VH. So no session initiation from vBond or vManage or vSmart. They will accept. They are responders. Only Vantage is the initiator.
Okay, so it basically needs to be troubleshooted from VH side if connectivity can be established first of all towards vBond, vManage, and vSmarts.
Right.
Okay.
Yes.
Okay. Thank you.
Okay. So any other clarification? I hope everything is clear from others.
Yeah, one more query I have. For the VH, this initially this have some basic details for vBond, so it will communicate or it will advertise the routes. Means how it is going to identify it need to be communicated to this vBond.
we need to apply the initial configuration. So VH, we console to VH, and we apply the basic configuration. This is needed. As I told you,
Yes.
vBond, VH, vManage, vSmart. These 4 devices needs basic configuration, and this basic configuration VPN 0 IP. Okay, it needs its IP. It needs its IP. It needs its IP. It needs its IP. This is IP based reachability. So for L3 IP based reachability via VPN 0, we need to assign the IPs. Next, system. Okay, under the system, a unique ID. What is the system IP for this? What is the system IP for this? System IP address for this? System IP address, and what site they belong to, and what organization name. Like if there is a certificate comes in, what is the organization name to validate? What is the organization name to validate? So system specific. And what certificate this is going to exchange, and what certificate base it's supposed to check for the trust. So certificate and then root certificate both should be updated. So vSmart, vManage, all Vanages and vBond should have the minimum configuration for VPN 0, system, root, and then the certificate for the local. Then only by giving the vBond local IP, when VH, okay, to what vBond is supposed to connect. Using this IP, it communicates. Then send the local certificate, then vBond sends the local certificate, validate again the root certificate base, and then under the organization, then DTLS or TLS, then further exchange takes place. The same thing, certificate, root certificate information system, again the similar process will be followed over here. All the devices must have VPN 0 and then system and certificate and then root certificate information. Along with this, on the controller side, whitelisting. So like what Vanages, what whitelisted Vanages comes in authentication. Similarly, what controllers are comes in for authentication. So whitelisting is available only on the vBond and then vManage and then the vSmart, the controllers. So these 4 steps of configurations are mandatory. 3 configurations are mandatory at Vanages. 4 configurations are mandatory at the controllers.
Okay, fine. And there is any limitation for the subnet? It should be on same subnet, or can be work if also are in different subnet?
No, there is no limitation of LAN subnet or the local subnet. It can be anywhere. vBond in APAC region, vSmart in US region, and vManage in maybe EMEA region. Vanages distributed across the across various places with different public IP addresses. Once the transport provides the reachability from one region public IP address to other region public IP addresses, then mutual trust or certificate exchange or every communication takes place. There is no limitation that controllers Vanages to be in the common subnet. They can be anywhere. They can be with any public IP address. They can be with any public or private transport. Only one thing, the TCP, UDP port numbers and the IP addresses should be reachable with each other.
Okay, thanks.
Yeah. Yeah. Okay. So in zero touch provisioning or maybe in zero touch provisioning or PNP, plug and play process, what normally we'll do. So we just consider the Vanage in the standard behavior or manual deployment, VPN 0 system and certificate. This is mandatory. In case of zero touch provisioning, even these configurations won't be available. The device will be a new branded device with no VPN 0, with no system or with no basic configuration. We receive the hardware from Cisco and we unbox it. We connect on the network via DHCP service. The router will take the DHCP via public DNS. They will try to reach the ZTP server, and then they will talk to vBond, they will talk to vManage, they will talk to vSmart, and they will participate inside the fabric. For PNP or ZTP, even the basic configurations about VPN 0 and system not required. Okay, how they are going to talk through their own fabric communication path, then ZTP or PNP process. We'll explain that. Allow me sometime. Tomorrow we talk about ZTP and then PNP, how they are going to discovering the vBond and how they come to know about the vManage and then vSmart IP addresses. Then they will be part of the fabric. All right, I'll go to the next one. So to summarize everything in here, control plane sessions in summary, vManage, vSmart 1, 2, and then vBond. So at Vantage perspective, so Vantage is going to communicate with vBond. So DTLS, this is always UDP based. There is no TCP based, and this is a temporary connection. So Vantage communicates with the vBond and exchanges certificates in both the devices and validation. vBond gives the distributed controller information, and then the session or the tunnel will be terminated. Okay, then Vantage talks with the vManage, DTLS, RTLS, UDP based or TCP based, which is permanent and single session is maintained, and then net config underlying session could be communicated. With vSmart 1, vSmart with 2 vSmart by default, it forms the OAMP session, DTLS and then TLS, permanent session, one session per vSmart and then per TLog. Okay, number of transport, each transport will make a session with the vSmart, and then OAMP underlying session will be communicated. Through OAMP, all TLog, all routing informations are received, and once they receive the other Vantages, Vantage to Vantage data plane, IPsec tunnel, will be built. So secure channel to sd-wan controllers, single extensible control plane, operates over DTLS or TLS, OAMP between Vantage and then vSmart, net config provisioning from vManage. Okay, so one device, okay, temporary session with the vBond, permanent session with the vManage, and using net config, this is maintained. Permanent session with vSmart and OAMP session will be retained. Between Vantage to Vantage, IPsec tunnel, a permanent IPsec VPN tunnels could be by default. Okay, so the standard port numbers, firewall port numbers for DTLS and then TLS. For the DTLS, Vantage to Vantage or IPsec communication always takes place in the port number 12346. With vBond, this again UDP based, UDP port number 12346. With vSmart and then vManage, it depends on number of virtual CPUs, number of cores we initialized. Each core or each CPU will be like initiated with the session. First UDP session to 1, 2, 3, 4, 6. Second UDP session 4, 5, 6, 7, 8, 9, 10. So they will be initialized in this manner. So number of virtual CPUs available, number of UDP sessions will be established. And then same behavior, TCP, always Vantage to Vantage, the data plane communication, all IPsec data transmission will take place through UDP on the standard port number. vBond to Vantages, always with UDP based session. So we don't have any TCP. Only with vSmart and then vManage, we have an option to run either TCP or UDP based connections. So TCP, then port number would be like 2, 3, 4, 5, 6, and then 5, 5, 6, 6, 5, 6, 7, 5, 6, 8, 9, and then 10, 11. It comes like this. Okay, so firewall port numbers to allow TLS based or DTLS based session between these components. So this is the mutual trust whitelisting and then mutual trust using the digital certificate for control plane session we wanted to discuss. Any question on this, we will talk about it. If not, we will break for food. I think it's 3:25. We'll take 1 hour lunch break and then we will join back.
Thank you, Pradeep. Can I ask you a question during the break? Actually, okay. Because it might be not really interesting to everyone, but I just wanted to clear my understanding. Right?
Okay, no problem. I'm there. Others, if you want to be in the call, you'll be with us. Otherwise, you want to leave for lunch, you can leave 1 hour and then we will join back. by 4:25, we'll join back. Nice. Go ahead, Sid.
Okay, Partly, if you can scroll back to slides where mutual trust and mutual certificates are actually going on. A little bit more back, yet more. Well, yeah, probably some way. No, it's probably on the right later on. But okay, let's keep it. Yeah, this one. When you have external certificates like Symantec, anything like that. Yeah, on the picture when you have root certificates from Symantec and things like that. So I think you had a slide where you have vSmart or vManage and a lot of VH devices, and they start exchanging TLS, building TLS tunnel.
This one?
No, on the right. The way how we setting up a TLS tunnel. Because in this case, on this slide it would be, on that slide it would be better to.
Okay, I will just run through the slides. You point one, from there we will start discussing. Then that will become easy.
Next. Hold on. Yeah, over here, for example. Yeah, secure control connection. That's right. So coming back to my actually initial question, right, about root certificates and how new root certificates need to be installed. So, for example, here you see that vBond certificate is signed by Symantec, right, from root authority, and the device certificate is signed by AVNet. Now, we come into a situation when the root certificate is getting expired. For example, it's been signed by Symantec CA, and this certificate for Symantec is getting expired. So we need to install a new root certificate for Symantec, right? Or let's say for AVNet, for example, right? So we do install it on vManage. Now, we basically need to, if we update it for AVNet, for example, we need somehow to make a new certificate from VH devices, from vBond devices, and things like that. For the big installation, it would be a lot of hassle to do it manually. What would be the process?
Okay, so what I can here is tell you, I go to the vManage. Now what happens? vManage will have the external CA reachabilities. For example, I need to install, AVNet certificate or Symantec certificate or even enterprise certificate. What happens? I need to update on vSmart, I need to update on vManage, and I need to update on vBond. What Cisco has done, already we have a trust with vManage and then vSmart. What happened? Once we enable the whitelisting between vSmart and then vManage, whatever the local root certificates are available. I do have a root certificate, and this root certificate is from AVNet, or it's available for HCL. So now once I add the vSmart, it's vManage chance to update it. It pushes it automatically, like root certificate AVNet, root certificate HCL, which is updated to vSmart. So vManage updates all the local existing root certificate to added controllers. Same way, this certificate is updated to this place. In case AVNet certificate or HCL certificate is about to expire, we need to renew it. We don't have to connect vBond to CA to update the certificate. We don't have to update the vSmart. So we obtain the new certificate, a new updated, a new renewed certificate for root, and then locally you modify and then update it here. The same thing will be synchronized to vSmart, and then same thing will be updated to vBond. This is applicable only for the root certificate process.
Okay. But for go ahead. Sorry.
At VH perspective, what happened? This VH, it's not going to have any control from vManage. So we have no other choice. This VH needs to talk to the external certificate authority and then download the renewal certificate for the root, and then locally it's supposed to be updated. So if you have more number of managed devices, if these devices needs to be updated for the root certificate, they have no other choice. They have to be updated manually.
Right, but here's I see. Well, I don't know. Maybe it's an illusion of a problem, or if it's real problem. So, for example, semantic, right? Because VH router has to mutually authenticate vBond, for example, right? So vBond would be sending its own certificate signed by semantic root authority, right? But if root authority certificate does not exist on VH, it cannot actually trust a certificate received from the vBond.
Yes, it rejects the certificate and it says control connections cannot be established. It won't go further.
Right. Well, fortunately enough for vBond, it's one time and it would be expired. Not maintained. But for vManage, for vSmart, for example, it's also mutual authentication. And so once we have a root certificate installed to vManage and we have a control connection from vManage to VH, is there the way to do it automatically, install it on edge devices, new root certificates?
No, we cannot do that. We will have to console to Vanages, or even we can make an SSH, but manually we will have to push the certificate for every Vanages locally. But there is an programmability access. In programmability, REST API calls, what you can do is you can keep a certificate in one common folder or in common one server. From there, you place a REST API call so that all the devices will talk to the certificate place where the certificate is available, downloads and installs it.
Yeah, I understand. Because of vManage API programmability, and basically vManage has a netconf communication to VHs, right? So basically, I believe you can instruct vManage to push and update the root certificate on all VHs. So you can get a list of active VHs, which is connected right now, and then push a new root certificate over there, install it. Using netconf.
Yeah, sure.
Okay. Yeah.
We'll see a probability to see some scenarios like this. Any Cisco D Cloud Labs or any public cloud labs are available to test this. If not, we will do it. If not, only theory.
No, it's okay. Thing is that for this new, let's say, solution, I would say in quotes, new solution, right? I would expect kind of fresh certificates are used. But what we've seen in the past, and basically it's one is happening really right now, about ICE, for example. So in ICE, there are a few old certificates being provided for root authorities, for CAs, and they are expiring. Well, a couple has expired already, and a few going to expire very soon. And so, yeah, that's why this question, I have this question. So probably it's not the case for sd-wan, because as I said, it's pretty much recent, and on recent installations, root authority is supposed to be pretty much fresh.
Next topic we discuss with the fabric operation. So the points what we discussed, the components involved in the sd-wan fabric, vBond, basically the orchestrator, vManage, decentralized management, vSmart, decentralized control plane, WAN edges, the forwarding devices. It's in both control plane and then the data plane. And then we talked about the whitelisting of controllers, whitelisting of managed devices, and also the mutual trust established based on the device digital certificate. So once the devices exchanges the certificate, DDLS tunnel, and then mutual trust establishment, we do have underlying communication between vSmart and then WAN edges. So basically like OAMP control plane communication, how it helps to form the VPN tunnel and a tunnel encryption and then decryption control. So fabric and then fabric related concepts we do talk about. So with fabric overlay management protocol OAMP, it's a single control plane protocol inside the SD-WAN fabric operated over OAMP. Control plane protocol distributing reachability. So this OAMP exchanges the reachability information. So reachability about the transport. Each service provider transport link IP addresses reachability is distributed by OAMP, and LAN side subnet called as service VPN routes. So LAN side network addresses, right? Routing updates like subnet mask, or the prefix and then prefix length. Okay, this is advertised over the OAMP protocol. Security as part of VPN communication, symmetric key encryption mechanism, asymmetric key encryption mechanism. So the key which is used for data plane encryption. So data packet encryption. This key exchange takes place over the OAMP and also policies. We do have centralized policy definition in the SD-WAN fabric. So these centralized policies will be communicated through OAMP. So one routing protocol, okay, exchanges various information. So the first information to carry the transport addresses. Let me type it here. The first one, OAMP exchanges transport details. So transport details like ISP links and then ISP link associated IP link properties. Then service VPN routes. So VPN 1 to 511 is called as service VPN or LAN site VRF. Any routes advertised on the LAN site towards to service VPN, they will be communicated through OAMP. And then IPsec encryption keys. IPsec data encryption keys are communicated over the OAMP protocol. Again, IPsec encryption key exchange takes place. And then fourth one, we do have policies. So centralized control plane policies and then centralized data plane and AAR policies. So control centralized and then data centralized and application aware routing policies, they are communicated. So one control plane protocol exchanges 4 categories of data, and each one will be used for its unique functions. Then we do have a terminology about transport locator. Each service provider connection circuit's identity, we name it as transport locator. So transport attachment point and next hop route attribute. If a WAN router is connected with MPLS, so MPLS link is considered to be created with a T-lock. If the same router is connected with internet link is created with the second transport locator. So the number of service provider link is used by WAN edge devices. So each link and each link identity is defined through transport locator. And color. So color basically is a syntax used to control the tunnel establishment. For example, route 1 to router 2. Between MPLS circuits or MPLS transport based VPN tunnel we wanted to enable, or internet 1 and then internet 1, internet to internet VPN tunnel we want to establish, or internet to MPLS VPN tunnel to be established. So the way like we want to control the VPN tunnel establishment over this circuit, is controlled through the color logic. So control plane tag used for IPsec tunnel establishment logic. So site ID is basically like a classification boundary, system IP address and unique IP address. Organization name is the basically to validate the incoming certificate. VPN, the VRF. So in Viptela, we do see VPN ID of 0 is called as the transport VPN or the control VPN. This is the transport or control VPN. And VPN 512 is the OOB management interface. Apart from that, 1 to 511 is called to be the service side VPN or service VPNs. And this VPN ID or this VRF ID is used on the LAN side. So all LAN side subnets will be called into service VPN, and from service VPN, routes will be distributed over the overlay network. So VPN is the VRF terminology. VPN 0 is transport, VPN 512 is OOB, 1 to 511 is called as service VPN connected over the LAN side. So inside the fabric, we do see various terminologies. The first terminology as OAMP, second terminology as transport locator, and third terminology is color, site ID, system IP address, organization name, and VPN. So transport locator, color, OAMP, and VPN. So these informations we discuss in detail using the other slides. So software-defined centralized control, virtual fabric over any transport. Normally, like controllers are deployed, and then WAN edges. Between the WAN edges, data plane session, data plane communication. Behind the WAN edge routers, we can have directly connected subnet, or we can run OSPF-based routing, BGP-based routing, or static routing. So routes will be communicated between these WAN edge devices via the controller, basically via the vSmart. So instead of full mesh neighborship or full mesh adjacency, we go for hub and spoke. Like vSmart will become the hub or route reflector, and then spoke devices. Basically, the WAN edges are going to be the spoke devices. So virtual or physical platforms of the edges are supported. Centralized reachability, security, application policies, single extensible control plane protocol, and then complexity is reduced by going with hub and spoke adjacencies. Okay, so OAMP, the first protocol. So TCP based extensible protocol runs between VH router and vSmart controllers, and also between vSmart controllers. So we do have OAMP adjacency like vSmart to WAN edges, and then vSmart to vSmart. So OAMP adjacency will be built. The point of what I mean to say it here, whenever we are introducing WAN edges, it can have vSmart 1, vSmart 2, vSmart 3, vSmart 4. So like though we introduce many vSmarts inside the fabric, by default 2 OAMP adjacencies will be built. So each WAN edge will form 2 OAMP adjacencies. That means it can talk to 2 vSmarts at the time. So forms 1 adjacency here and then second adjacency. And then default behavior is 2, but it can be incremented maximum of 3. So 3 vSmarts can be introduced per fabric or per group, and by default 2 is enabled. So each WAN edge router forms 2 OAMP session. So in this picture, you can say like 3 sessions are enabled. It's like a maximum capacity, but this WAN edge forms first session here and then second session, and this is not going to be enabled by default. So WAN edge devices, again vSmart OAMP adjacency and then vSmart OAMP adjacency. Then third is committed over here. So between vSmart to vSmart, OAMP adjacency could be triggered. So runs between WAN edge routers and then vSmart, and also between vSmart devices. Then OAMP exchanges T-logs. So transport located. These are the transport information. OAMP advertises T-log routes, and OAMP advertises unicast, multicast destination. So they are learned through service side routes. Basically, service VPN routes 1 to 511. This is the second type of routing table update is communicated over OAMP. In case any L4, L7 devices are introduced, we attach a firewall we attach a load balancer, or we attach any IDS and then monitoring any L4, L7 devices. To announce the location information about these devices, L4, L7 routes will be generated. And then IPsec encryption key exchange takes place, then policies. So centralized control, centralized data, and then AAR policies are communicated through OMPs. So finally, you can say like one routing protocol exchanges transport locator routes, exchanges service VPN routes, exchanges the service function routes like L4, L7 routes, exchanges IPsec encryption keys, and then exchanges or communicates the centralized policies inside the fabric. So 5 different informations are communicated using one protocol. Our traditional protocols like OSPF or BGP or EIGRP cannot be used between WAN edge routers with the vSmart, because this protocol exchanges only the routes. TLOC exchange or IPsec encryption key exchange are not supported over here. So only the supported routing protocol inside the fabric between vSmart and then WAN edges or vSmart to vSmart is a OMP protocol. So one routing protocol exchanges 5 different data or 5 different types of control plane update inside the fabric. Any questions in this place? Okay.
Sorry, it is not exchange any data. It's only for control and management, OMP.
No, OMP is a control plane protocol, and vSmart sits only in the control plane. vSmart is not part of the data plane, so no data packets from WAN edge to vSmart or WAN edge to other WAN edges via vSmart takes place. Only the routing table update or control plane update will go to vSmart. vSmart will not be part of the data plane at any situation.
Okay, thank you.
Yeah. Okay, so we do have WAN edge 1 and then 2, 3, 4, and they do have the DTLS circuit. Over the DTLS circuit, OMP session created. Okay, now we talk about the TLOC. Before we understand OMP, so the first routing table update as the transport locator and exchange with this TLOC, we understand it. Okay, now TLOC. So as I told you, this is for transport identity. Okay, so now this transport locator is derived using various information. So this transport locator is derived using system IP address of the device plus the transport color. So each interface or each transport is given with its unique color, MPLS, internet, public, private, gold, silver. So each transport is given with its unique transport name or called color, and then encapsulation. So this is supported with, or VPN tunnel is supported with IPsec as well as GRE. What GRE or what IPsec based encapsulation we are going to form over the tunnel interface, we will enable. So TLOC is derived using the first main attribute of system IP address, color of the transport, and then encapsulation enable inside the interface. Along with that, and the IP address. So what IP address, like what public IP address or what physical IP address is available on the interface, and then the device belong to the site. So what site ID the device is belonging to, site ID. Okay, plus we can say like weight, preferences. Again, you can say like some tagging, weight values. So some of the other additional information should be applied for that. So TLOC is going to have the identity for each transport using system IP, color, encapsulation, IP address available on the interface, and the site ID of the device belongs to it. Then you can say like tag or weight, and then preferences So these things, all are additional things will come in over here. Okay, now what I can give you here as an example, I'm connecting one transport. Let's say this is my MPLS transport. MPLS transport. The moment I connect the device 1, for example, device 1 is connected on MPLS. So now this device physical interface called as part of the VPN. So 0 by 0, let's say. In Edge, we do have the basic configuration for VPN 0, and then we try to map the interface or interface gig 0 by 0 IP space address. Let's say 63.0.0.25/24 is a physical IP address on the interface, and I will make this is tunnel interface. This is an additional keyword what we are trying to use it. And encapsulation, we are trying to say this is enabled with IPsec. And color, this is going to talk to MPLS. So I'm just giving the color for this as MPLS. So this MPLS keyword is our own definition. So depends on transport, we can just give MPLS, internet one, anything like we can be able to name it. Under this system, this device is going to have the system IP address defined. So system IP address as, let's say 192.168.1.1. And then it belongs to the site ID of 100. Then organization name, whatever may be, additional parameters to be utilized. So now Vantage 1 using its gig 0 by 0 interface connected to transport 1. So now this device creates its own TLOC. The first TLOC generated by Vantage 1. It says it's connected to transport 1. So TLOC 1 is generated. System IP address 192.168.1.1. And then color is connected over MPLS. And IPsec is an encapsulation procedure. And this IP address is 63.0.0.25 and belongs to the site of 100. Okay, plus additional configurations what we try to include it here. So Vantage 1 generated its own TLOC, TLOC number 1 as 192.168.1.1, system IP, MPLS, and then encapsulation, public IP address, and the respective site IDs. Same behavior if I'm following for VH number 3. So it creates its unique TLOC. When this is connected with MPLS, this one will have its own TLOC generated. So here MPLS connection, trying to connect with a different physical port, gigabit Ethernet 0 by 1. And based on the interface configuration, let's say this is 98.0.0.50. And the system IP address is configured as 192.168.1.3. Okay, now color, we try to give the same for MPLS and then IPsec. When this is generating the transport locator, it says system IP 192.168.1.3, and color is MPLS same color, and encapsulation is IP security, and it belongs to the public IP address of 98.50.0.0.98.0050, plus it belongs to site, let's say it's 200. So depends on the number of transport connected. Each transport will be created with its unique TLOC addresses. So transport locator. So basically transport locator is for transport identity. And this TLOC is derived using system IP, color, encapsulation, public IP address on the interface, site ID, tag, weight, and then preferences values. Any questions at this moment? Yeah, so so what VH1 have, VH1 is connected with the MPLS transport. So if this is generated its own TLOC, that means VH1 has one transport connected, and this transport information is derived using its local TLOC 192.168.1.1 local system IP. And this interface is configured with the color name of MPLS, and this interface is enabled with encapsulation of IPsec, and this interface has this public IP address, and this device belongs to this site ID. That means router details as well as interface details. So both are carried over TLOC1. Same thing is applicable on the third router. Third router is connected with the MPLS. So when this is connected with the MPLS, it will generate its own local TLOC. So system IP address and then site ID and what interface color encapsulation and then what public IP address is available on top of it. If this device is connected with this transport using this interface IP address and then device detail, it creates its own TLOC. So it creates its own TLOC. This creates its own TLOC. So each route connected to the local transport is responsible to generate the locally generated or local TLOC. Right. So once the transport locators or TLOCs are generated, so now what happened? TLOC1 got generated, and this TLOC1 is exchanged to vSmart via OAMP. So OAMP comes in picture here. So OAMP TLOC advertisement. So first type of routing table updates are OAMP routing table updates. And this OAMP routing table update carries TLOC1. So in vSmart, we can say first TLOC as 192.168.1.1 plus MPLS is the transport color. MPLS and IP security. The public IP address is 63.0025 and then site ID is 100. So now received TLOC is distributed to all the WAN edges. So with this vSmart sends first TLOC advertisement here, second TLOC advertisement here, and then third TLOC advertisement here, and then fourth TLOC advertisement here. The way like routing table updates are distributed by an router, similarly vSmart receives the OAMP routing table update including this information, and this is advertised to all the WAN edges under this vSmart for OAMP sessions. Now WAN edge number 3 receives it. For example, here in the received, you can say like TLOC received, TLOC1, 192.168.1.3, and then 1.1 MPLS, IP security 63.0025, and site ID 100. So this is going to receive the detail. Now router 3 or WAN edge 3 has a locally generated TLOC and it has the received TLOC. Now received and then local TLOCs are compared and depends on the interface color configuration, MPLS and then MPLS. So same color is available, same color tunnel establishment could get followed. Now it says I have received TLOC number 1 using this system IP address using this public IP address. So a VPN tunnel, an IPsec based VPN tunnel should be triggered source IP address of 98.0.0.50 and destination IP address of 63.0.0.25. And same thing happens in the other way. Now whatever the TLOCs generated by device number 3 sends its own TLOC, and this TLOC is updated on the vSmart database. So 192.168.1.3, and this is MPLS and IP security. This is like 98.0050 plus the site ID of 200. Now same thing is communicated to other devices. Now here this is communicated to first device as well as to other devices. Now in that received TLOC, it says 192.168.1.3 using these public IP addresses. So now you will try to initiate the session towards to these IP addresses. So using the received TLOC, both source and then destination devices come to know about the public IP addresses and what transport they are connected, what encapsulation, what VPN tunneling mechanisms to be followed. They are cross-checked, then VPN tunnel will be built using its public network. For example, using its IP address based network path. A data plane tunnel, a VPN tunnel, will be established between the source IP address of 630025 to the destination IP address of 980050. Okay, so the idea behind here, by exchanging the transport locator addresses, so every router's transport information, what transport they are connected, on what public or private IP addresses they are connected, so that once they are exchanged, then VPN tunnels will be triggered to the specific or to the received TLOC addresses. So first type of routing table updates are TLOC addresses. By exchanging the TLOC addresses, automated VPN tunnel establishment takes place between these vantage devices. Okay, so any questions or any clarifications, I can address it now. Yes, we do have. Even we go to vSmart and show OMP TLOCs received and show OMP TLOCs advertised. We can cross check. Even on Vantage, Cisco devices or Viptela devices show OMP TLOCs received and then advertised. It shows locally generated TLOCs, and also it will show the received TLOCs. Yes. Okay. Yeah, VH1 will show locally generated. Local TLOC database will have the locally created. Received TLOC, it shows 1, 2, 3, 4. There are 4 TLOCs received, it shows. Yeah, so per transport, every transport will have one TLOC generated. They will be connected in this.
Okay, and if a little bit complicated scenario, so if VHs are behind NAT, right? So you need to have a static NAT configured for, or a static path configured for IPsec tunnels and things like that, right? So in order to create IPsec tunnel in between two VHs, you would need to have a specific path configuration, static.
The underlay configuration, right? You mean to say?
Yes. Yes.
Yeah, underlay configuration is mandatory because we are going to form the overlay VPN tunnel between 630025 to 980050. Obviously, over the transport, it should have a reachability between this. So underlay configuration, so that over the underlay, overlay VPN IPsec will be built. So why we are coming to the TLOC in a traditional design, in a traditional security design, router 1, router 2, they are about to form a VPN tunnel. In router 1, again, ISA KMP phase 1 configuration, IPsec phase 2 configuration. We need to give what is a peer IP address and then pre-shared key or digital certificate. So we will have to manually configure them so that tunnel will be created. If more number of devices are introduced and the configuration to every device becomes complex, so they want to automate it. In this case, what happened? Every device, okay, takes its local public IP address and then communicates to other devices. When everybody else in the network receives the public IP address, they will come to know this is the IP address to which the VPN tunnel, to be established. So the devices will receive them and they will trigger the VPN tunnel, automated VPN tunnel IPsec or GRE will be established. So just to form the VPN tunnel, automated IP address distribution through transport locator. Okay, this is happening using OMP routing table update 1.
Okay.
Okay, and if I have next to transport, this is like one transport. Okay, so MPLS. Suppose I do have second transport. All the devices are connected with the second transport, redundant path. Okay, so now router 1 has first link to MPLS, second link to internet. Similarly, like all 4 devices have first link to MPLS and then second link to internet. So each device will generate 2 transport locators. For an example here, This generates the second T-lock. You can say like T-lock number 2. And this T-lock 2 comes from 192.168.1.1, same system IP address, but color I can make it as gold. So this is the configuration name, what I'm going to give it for the link. And this is again IPsec encapsulation. And we try to go with a different public IP address, 120, maybe like 1.0.12.35, plus it belongs to site of 100. So when second link is connected with the transport, then second link information, same system IP, encapsulation and then coloring format like IPsec and then gold, then public IP address available on the port, and then the system IP address. Now in this case, then a new generated or the second generated T-lock will go to vSmart. Again, they will be updated and they will be updated to other devices. Now router 4, router 5, they will receive the second T-lock, they will compare it. So 192.168.1.1 gold color and then IPsec, a new T-lock has come. Now they will compare. Again, this is like one is with MPLS and then one is with internet gold. And what is the behavior like internet to internet VPN tunnel or MPLS to MPLS tunnel or intercolor communication again to be there. So we have a keyword called color MPLS restrict or just color MPLS. If we just give color MPLS, from MPLS to internet and internet to MPLS, intercolor VPN tunnel gets established. But if you are introducing the keyword called restrict, this is included with a keyword called restrict. You can type it here. So when we enable with restrict keyword, then same color tunnel gets established. Restrict. So MPLS to MPLS only tunnel will be built. Internet gold to internet gold, the tunnel will be built. So we just enable this keyword, restrict keyword, along with color MPLS restrict options. So interface specific configuration for IP and tunnel configuration, encapsulation, color, and then color and with restrict or color with no restrict, system and then system specific parameters. So each device depends on a number of transport they are connected. Then transport locator addresses are generated. By exchanging the transport locator addresses, automated VPN tunnel gets triggered to these public IP addresses. Okay, so this is the information I wanted to cover as part of T-lock. So any more clarifications required, I will address it. If not, I'll move on to the next slide. No, at this moment, bandwidth considerations won't come in picture because these are all, again, connection establishment. They will go as a control plane data only. So no data or no actual client side or service side VPN data discussions we have talked about. So this is like the way how devices exchanges the control plane information to form the automated VPN tunnel. If you look at the sequences, only configuration what we are going to do, we go to each and every component, VPN 0, system configuration, and certificate update. Once this is done, Vantage will talk to vBond automatically. Vantage will talk to vManage automatically. Vantage will talk to vSmart automatically. Forms the VPN, for example, forms the OMP session. Once a OMP session is updated, it collects all the transport locator addresses automatically generated, then VPN tunnel will be automatically built. We don't have to make any VPN tunnel specific configuration to any other devices. So automatically the VPN tunnel will be built. Okay, you are exactly right. Nothing new, no new concepts are introduced here. IPsec VPN tunnel and also DM VPN. So both are combined and they are just made it as everything is automated. So automated IPsec VPN tunnel, like between spoke to spoke, so spoke to hub, wherever it is required. Like full mesh VPN tunnel establishment between all Vantage devices. All right, I'll go to the next slide. vSmart Vanages. So the devices are connected with the local transport. So each device generates its own local T-lock. So T-locks using system IP address, color, and then encapsulation. Then T-locks are advertised to vSmart, and then vSmart advertises T-locks to all managed devices and can be influenced by control plane policies. So what I mean to say it here, if T-lock 1 and then T-lock 1, if these two T-locks are sent and then communicated via vSmart, VPN tunnel will be built between these two. Somehow we put a policy saying that this vSmart don't accept this T-lock, or vSmart don't advertise this T-lock. If you apply a policy not to advertise any T-lock or not to receive any T-lock, then if this is introduced, then obviously to the T-lock restricted, the VPN tunnel will not be built. If you say like, I don't want to form VPN tunnel for these devices, okay, this vSmart, if this is not receiving any T-lock, or if the T-lock is not advertised to any other devices, they will not come to know about the information about WAN edge 1 and its T-lock addresses. VPN tunnel cannot be established towards these devices. So by default, full mesh tunneling or full mesh tunnel will be established between all the devices. And if you want to control, then policies will be introduced, and then policies will influence, depends on our behavior.
So the full mesh is set up even if no traffic is actually sent, right? So it's just pre-set up stage.
Yes. Okay. So whether the data is available or the interesting traffic is there or not, a full mesh VPN tunnel will be established between all the WAN edges. That's a default behavior.
Okay.
I think it depends. Like there is a formula. I'm not sure. Like 2 to the power n minus 2, something like that. But as for me, like it's like full mesh. I mean, you can say like hub and spoke. We try to have except the source to all the WAN edges, the tunnel will be built. So here you can find after exchanging the transport locator addresses, this is like a transport 1. It has first tunnel to transport 1, and then second tunnel to transport number 2. Like there are 2 tunnels going here. So from here, tunnel 1 and then tunnel 2. From same device, tunnel 1 and then tunnel 2. So tunnel 1, tunnel 2, tunnel 1, tunnel 2. So there are like 8 tunnels using first transport. So 8 tunnel using the second transport. If color restrict is enabled, for example, if you enable restrict, from here MPLS to MPLS, first tunnel MPLS to MPLS, MPLS to MPLS, MPLS to MPLS. So MPLS to MPLS 4 tunnel, internet to internet 4 tunnels. So total 8 tunnels you can see. But here you can see 16 tunnels. But depends on our requirement, or depends on our situation. Intercolor communication or same color tunnel establishment logics we wanted to follow, we can enable it. All of them are interface specific configuration. Apart from that, we don't do anything at device level. So here VH1 connected to public and then private to transport. So it generated T1 transport locator 1 system IP color public, and then the IP address encapsulation, and T-lock 2 system IP private, and then IP address plus additional information. WAN edge 2 T-lock 3 and then T-lock 4 by exchanging the T-locks via OAMP. So local T-locks generated, received a T-lock, locally generated T-lock, and then received a T-lock. Then formed the VPN tunnel. So if restrict is enabled, T1 to T3. So T1 public to T3 public. So public to public 1 tunnel will be created, and then T2 to T4 second tunnel will be created. If this is disabled, then intercolor tunnel. So T1 public IP address to like private, and then private to public. So 4 tunnels, will be built. So from one T-lock to all the other T-lock, all the other available colors, the VPN tunnel will be automatically built. Okay, so this is the T-lock. And before I go to the OMP, I just show you this option. Each device local configuration and locally generated T-lock and received T-lock information. Let me go to the lab. I go to the devices and look them are registered. So I'll go to the CLI. As per our topology, so this is our topology. So if I go to branch CE1, so interface 1, interface 2, so connected to first transport here and then second transport. There are two transports. Now branch CE1 generates two transport locators. So T-lock 1 to gold and then T-lock 2 to silver. Same way branch V2 gold and then MPLS. So two T-locks would be generated, 3 and then 4. So normally this is called as T-lock extension. We will discuss later. So branch 3 and then branch 4 will have first connection, first transport to gold and then second transport via the peering device. So NAT is configured here, network address translation. So using this private IP NAT translation, using the public IP address, it communicates with this MPLS network. So branch 3 and then branch C4, like the fourth devices, these two devices are going to be with both gold and then MPLS transport. So 7 and then 8 silver and then MPLS, and then 5 and then 6 so internet and then gold and then MPLS transport. So like each device is available with the two transport connected. You can see like number of tunnels built between these components. So now what I will do, I'll go to the third device, so which is permitted. Apart from that, all of them are user restricted. So 1 and then 2 we are supposed to deploy. I have not deployed anything, but the deployed devices I don't take it. So branch CE3, third device, 2 T-locks generated and so many T-locks received. You can say T-locks from here, T-locks from other devices received. You can see it here. Let me go back. Branch CE3. Show sd-wan, OMP, PS. The number of OMP adjacencies. So with 16 and then 17. So 172, 10, 16 and then 17. This is vSmart 1 and then vSmart 2. There are two vSmarts available in my code. So two OMP adjacencies are built. And show control the other sessions we wanted to make sure. So show sd-wan, control connections. So with vSmart DTLS up, with vSmart DTLS, vSmart DTLS, and then we manage DTLS. So it has established DTLS session, private IP address, and then public IP address. Using what transport this is connected, we can see it. Now show sd-wan, OMP, T-locks. Okay. So now T-lock entries for 172, 130.3. This is locally generated. You can see 3. Okay, 3 is basically the router number. This is router number 3. This is generated the local T-lock for MPLS and encapsulation IPsec, and it advertised the public IP address of 10.1.13.133. Okay, so you can see it here. The third device, when this device is connected to 1.13.113. So this is the IP address it generated towards to MPLS transport. So first TLOC generated. We can say like 10.1.13.133 is the IP address generated. Then 172.130.3 with gold transport and then IPsec. So 1.1.12.13. So this is the second link. So 1.1.12.13. So this is the router number 13. So this is the second TLOC generator. So it generated TLOC 1 for gold, then TLOC 2 for MPLS. So two TLOCs generated locally. Apart from that, this is received. So 172.130.4, it's received from 16 first vSmart, and you can find the IP address as 10.1.14 and then 14. So 10.1.14.14 port numbers. You can see like site ID, the device belong to what site, and weight, tag, preferences, other values. You can see so many values in this place. So 170.100.5. This is the fifth device belong to site number 100, gold, and then IPsec 1115.15. So fifth device is here. So 1115.15. That's a public IP address connected to gold. So you can see like the TLOC received for this particular devices, and the device belong to site ID 100, received from 16 as well as 17, 170.100.6 MPLS and then IPsec. Again public IP, private IP address, then site ID, they belong to 100. So like every device and associated TLOC entries available, we can be able to cross check it here. 172.1.200.7 MPLS. So when this is connected and uses 20.17 IP address. So this is a 7, again 10.1.20.17. This is IP address, this is connected over the MPLS path. So 10.1.20.17 IP address, public. So 170.1.270. So 1 to 19 and then 17. So here this 1 to 19 and then 17 with this internet. Okay, so each device and associated TLOC derived, and this is connected. So now what I can show here, show sd-wan running configuration. Now the configuration. Okay, so the tunnel interface, this is the command I wanted to show it here. Interface tunnel 1. Okay, so interface tunnel 1 and then tunnel source, tunnel destination, then tunnel mode sd-wan. So the tunnel interface created and then tunnel specific configurations are introduced. So sd-wan, and see it here, color gold is introduced. If this is enabled with restrict option, obviously like gold to gold only tunnel will be formed, gold to different transport tunnel will not be formed. At this moment restrict is disabled, so tunnel should be available for this. So tunnel interface and this is MPLS restrict. So MPLS restricted is enabled, tunnel will be from only to MPLS to MPLS. Let me show the commands for the tunnel. Show sd-wan, IPsec, inbound or outbound connections. So inbound connection, okay, so there you can find MPLS to MPLS. So MPLS is enabled with restrict. So MPLS to MPLS, MPLS to MPLS, the tunnel is built. But here silver to gold and then silver to gold, gold to gold. So different color or intercolor VPN tunnel gets enabled. So even if this interface or this color is enabled with restrict, same color only the tunnel you can be able to see it. I can show you that. So color MPLS and then gold, silver. Let me check the configurations here. Show sd-wan Running configuration. This command is not supported because this is in the vmanaged mode. Let me check any device with local support. Okay, so all the devices are in the template-based mapping. In this case, we cannot be able to update it locally because all configurations we needed to do it through the template. Maybe I can do some modification through the template. C3. Okay, let me modify this template. Branch C3 is a keyword I need to search. It has so many interfaces to 3041 and then 2. Let me edit the one which is configured as code. Tunnel interface.
Are you creating the template? Or
No. This is available already. I'm searching the place, the option to be disabled. That means I go to the template and restrict option, I'm going to enable it.
Okay, so template creation we are going to cover later.
Yeah. Tomorrow we will talk about that template. But today I just want to show you the restrict option, how it works.
Okay, fine.
Because I don't have any other device in CLI mode, local CLI mode, so that we can easily modify it. So I need to edit through this template. Branch C3. So tunnel interface is on. Now I can see here. So tunnel interface is on and color is gold. Restrict is disabled. So I just enable this. Now before I'm enabling the restrict, I can see number of tunnels. Show sd-wan, IPsec, inbound connections. silver to gold, there is a tunnel. Similarly, we can use outbound connections as well. If any connections originated from this machine, gold to silver, gold, silver. Okay, so now this number of tunnels gets reduced after implementing this. Try to make it is in progress. It's success. Show running configuration. So now we could find under sd-wan interface gig 1, so color gold restrict. So previously restrict was not enabled, now it's enabled. And similarly for the other color MPLS restrict. Now show sd-wan, IPsec, inbound or outbound connections. So we can find gold to gold. So gold local color and then gold remote color. So between same color, the tunnel gets established. Again, MPLS gets enabled. So this is our wish that whether we wanted to form the VPN tunnel between same colored transport or a different colored transport. So using the color restrict option, we can control this tunnel establishment logic. So if I go to the GUI and then monitor network, we can choose any of the devices. For example, I choose the DC file. We can choose the real time. And whatever the show commands we wanted to apply it here, we can do it. For example, OMP peers. So 16 and then 17. Then IPsec, inbound connections and then outbound connections. The number of VPN tunnels, source IP, destination IP, source port, destination port, local color, remote color. So either we can execute the command in CLI, this is a CLI mode output, or we can verify the same thing in the GUI. We go to monitor and then we choose the device, and with the real time, whatever the commands we wanted to execute, we can enable it here in this place. So transport locator, the local identity information to the transport by exchanging the TLOCs via OMP to vSmart, then it helps to form the VPN tunnel between the devices. So it depends on the interface configuration, tunnel establishment logic, and then tunnel encapsulation gets decided. So any questions in this place before I move to the OMP? Okay, fine. So All right. So OAMP, the three different types of reachability information. So OAMP advertises, OAMP routes. So prefixes learned from site local or from service side VPNs, and T-locks, basically T-locks to form the VPN tunnel and to announce the L4, L7 informations. So like a firewall or any L4, L7 devices and then location identity in this service function routes or network service routes will be generated. So every router, every Vantage routers generates three types of OMP routing table update. First, OMP routing table update includes the T-lock information. Second, routing table update is for the service VPN, like the standard routing protocols update messages, prefix length or subnet mask, and then associated metric value. Then third is the information about what L4, L7 device is connected, whether it is a firewall or the load balancer, and what physical port they are connected, what is the listening IP address, and what site it belongs to. All the L4, L7 identity information will be communicated to network service routes. So T-lock routes connecting locations to physical network, attributes T-lock private IP, T-lock public IP address, and weight, preference, color, tag, site ID, and then encapsulation. So the device specific information using site ID and then system IP address, link specific information about the interface. So the T-lock gets generated. The interface IP address, interface color configuration, interface encapsulation, which is get added with the site ID, system IP address plus additional value of it. So system IP address, then second link information. Using the second link information, second T-lock gets generated. Then OMP routes learn from site local network. Route types, it may be directly connected routes or static route configured under the VPN, service VPN, or the routes learned through BGP, or routes learned through OSPF, or routes learned through EIGRP. So to advertise these routing updates or the subnet information, attributes will go as T-log. This subnet, this network address belong to, or this is advertised by what T-log system IP address, and then site ID of the device, and the route belong to what VPN, tag, preference, originator, and then originator protocol. So we can find like OMP service VPN route and its advertisement. So route for 10.2.00/24 and the peer status, and then originator preferences and other configuration like T-log, which device is advertising this route into SD-WAN fabric. So OMP service route attributes, basically like what kind of device is connected. We connected a firewall or IDS or IDP or generic service, and under what service VPN this is connected, originator, which router is advertising this firewall information, and then T-log address of this, and then path ID. So like it's a unique identity will be created for it. So these three different types of routing table update. So Vantages about the transport information in the name of T-log routes, and service side VPN routes, and then service side VPN network addresses in the name of OMP routes. And in case any L4, L7 device is connected, then this device's information, L4, L7 devices are communicated using service route. So three different routing types will be generated by each Vantage router, and this is communicated via OMP to vSmart. But this is optional. Whenever we try to connect any L4, L7 devices, this is generated. If not, this two standard routing table update will always be generated, because T-logs are mandatory. Based on that, only VPN tunnel will be established. When service VPNs are generated, LAN site subnets will be redistributed into OMP, and then it's supposed to be advertised. So this service side OMP routes and then transport side T-log routes, so both will be by default generated by all Vantage devices. Okay, so data plane establishment, it's the same information what we are trying to analyze it here. So local T-log, system IP, color, public IP port, private IP port, control plane channel to vSmart. T-logs are advertised to vSmart, and then vSmart to all the devices, and SD-WAN fabric with full T-log as the tunnel establishment. And then VPN1, VRF1. So VRF1, any route is introduced in VRF1, automatically from VPN1, route will be distributed via vSmart into this. So VPN1 routes will be automatically synchronized. And if I go with VPN number 2, so if any route comes into VPN number 2, it goes to vSmart, and wherever VPN2 is active, automatically route will be advertised. That means same VPN and same VRF routes will be automatically synchronized with all the WAN edges available inside the fabric. There is no additional configuration for a route target, route distinguisher, import, export. These configurations are not needed. Router 1, WAN edge 1 is with VPN 1, and router 2, VPN 1, router 3, VPN 1. The moment a subnet comes into router 1's VPN 1 or VRF 1, immediately this will be updated to router number 2 and then router number 3 in same VPN. So same VPN routes will be automatically synchronized through OMPs. In a situation we want to make inter-VPN or inter-VRF communication, by default they are not permitted, but by introducing the policies, control plane policies, we can be able to enable like inter-VPN communication. So route will be distributed from one VPN to another VPN, and we can be able to achieve that. But as a default behavior, same VPN, same service VPN routes will be announced, and then they will be synchronized with each other automatically. Any questions in this? So sd-wan, basically like you can see VPN 1. In VPN 1 there is a prefix, so site 1 prefix A, and this VPN 1 site 1 prefix is announced over the OMP routing table update. So prefix A is reachable through TLOC 1, TLOC 2, TLOC 3, which goes to vSmart, and then vSmart advertises to the destination device and vice versa. If any data comes in, so incoming data, the next hop IP addresses are T1, T2, T3. From here, I do see T1, T2, T3. There are 3 tunnels pointing here. The tunnel which is best performing, so tunnel quality is measured via the best performing tunnel, the data transmission will take place. There are 3 tunnels pointing to the same subnet or towards the same VPN ID of the destination, but tunnel 1, tunnel 2, tunnel 3, each tunnel's quality will be measured. So tunnel quality measurement through BFT, we'll discuss in the data plane side. So the best tunnel will carry the traffic from source device to the destination devices. The routing table update will go in one direction. So data plane traffic will be on the other way around. So for the underlay and then the data plane communication, we do have multiple path reachability, multiple TLOCs, and then multiple tunnel established. And whatever the tunnel is best behaving, the traffic will get permitted. So this is the point I want to cover as part of control plane. In control plane, whitelisting, mutual trust, and OMP. Any questions and then clarifications I will address. If not, I will make you to practice. If not, like you'll get bored, like so many information in one first day itself. So you can get into the lab, whitelisting the WAN edge, whitelisting a controller, and building the control plane and then fabric communication path, enabling OMP, disabling OMP, verifying the TLOC routes, tunnel establishment logics, everything, you can check it. So any questions on the control plane? I will address it.
Maybe a quick one. Information about the different VRFs or VPNs, right? And you're saying that it's possible to do inter-VPN routing. Where would it be controlled and filtered? It's on vSmart. So basically, vSmart receives all information from one edge and see what should be redistributed into different VLAN.
Yes, we do enable this control policy, and this policy is executed at vSmart level. So it receives from VPN 1 and then installs into VPN 2 or a different VPN. So vSmart is the one executes all the policies and installs these routes.
Okay, so one edge is basically sending everything, control information, what it has, and vSmart decide what needs to be propagated on to other peers.
Exactly. Yes, you're right.
Okay, thank you.
Yes, so the routers will have a SIM module. We will insert the SIM, and via the SIM they will talk to GSM. That is mobile network. Okay, so LTE interfaces or GSM, it depends on the hardware model. We can say like 3G connection or 4G connections to the service provider on the mobile network. They will receive their own public IP, and using the public IP, they do have internet reachabilities. The way mobiles are connected, routers will be connected with internet. Okay, all right. So we start with the lab. I will share the lab credentials to you. Before we go to the lab, first lab number 1, onboard vSmart controller. This is whitelisting a controller of vSmart. So these steps will tell you like assigning VPN 0 system configuration for vSmart 3, and then installing the device certificate, installing the root certificate, and using the vbound IP address. vSmart will be part of the fabric because the fabric is already set up. Similarly, how to add Vantage. For example, Viptela Edge router. Viptela OS commands will come in here. Cisco Vantage. This is CH. Cisco routers command will come. Cisco iOS based commands, and then Viptela OS based commands to onboard it. Creating VPN 0, creating system configurations. This is what we are trying to do it. And additional configuration like system sd-wan, sd-wan tunneling configurations will come for vEdges and then ch. Then activating the chassis id and the token. So this command will tell like what chassis id and then what token we are using to activate this Viptela virtual machine based router. And this is like activating the chassis id and then OTP using Cisco ch, like virtual image of the devices. Okay, so we do enable VPN 0 and system configuration for both the devices. In this place, we do enable system configuration, along with we try to enable the certificate based or certificate installation process. Once this is done, fabric will be set up. In lab number 9, we do have OMP, shutdown OMP and no shutdown, creating VPN 1, service VPN 1 to be created. So adding some subnets inside that. You don't have to go till lab number 9. So what we can do here today, lab number 1, onboard vSmart controller. Lab number 2, prepare Vantage router onboarding for vEdges and then chs. And 5 and then 6, we can do it. So 7 and then 8, it's just a testing. Once the device is commissioned, how do we decommission and then how do we put it back the same device or with the different devices. So again, we will redo the same configuration in lab number 7 and then 8. So if you are interested, you can do it. If not, then you can try up to lab number 7. So we start with lab number 1 and then lab number 7. We do it for today. Since we have 6 students, I will share the lab. What I will do is I will create breakout session. In each breakout session, I will keep 2 students. Maybe like one of you configure it and share your desktop to the other student, and tomorrow I will swap it. The one who is listening today, tomorrow you will configure, then your partner will take a look on it. Okay, so I will create the breakout session. I will allocate you in it. Then 1:2 sharing basis. You can practice your configuration. I will be available on the main bridge. Anytime you want to ask help, then you just make a note of it, and then I will be in your bridge. Any preferences on your breakout session so that I will create in the same way?
Yeah, Mani, Vipin this side. You can give one ID to me and Sachin.
Okay, just a minute. System, any preferences? I'll keep Akhil and Piyush into session number 2.